The Big Bang did not bang. There was no sound, no explosion, no dramatic flash of light tearing through an empty void. The greatest misconception about our universe's birth isn't just a semantic error. It's a fundamental misunderstanding that has clouded our cosmic vision for generations. What if everything you've been told about the beginning is wrong? Not just incomplete, but fundamentally, shatteringly incorrect? You've seen the illustrations. A singular point erupting into existence, matter and energy spraying outward like cosmic shrapnel. It's a compelling image, one that has taken root in our collective imagination. But reality, true cosmic reality, rarely conforms to our human need for neat, comprehensible narratives. The universe doesn't owe us simplicity. What if I told you that there was no before the universe? That time itself began at that moment. That asking what existed before the Big Bang is like asking what's north of the North Pole? The question itself breaks down, becomes meaningless at the boundary of existence. Our minds rebel against this notion. We're trapped within time, prisoners of linear thinking. Past leads to present leads to future. Cause precedes effect. These are the foundations of our perception. But at the quantum scale, at the cosmic boundary, these foundations crumble. Look up at the night sky. The darkness between stars isn't empty. It's brimming with mysteries that defy our most sophisticated mathematics, that break our most elegant theories. Each pinpoint of light you see is not just a star, but a window into the past, a glimpse of something that might no longer exist. When you stare at the night sky, you're looking at history. Fragments of light that began their journey millions, billions of years ago. You're not seeing what is. You're seeing what was. But what about what will be? What about the core, the heart of it all? What secrets hide at the center of existence? Imagine rewinding time. Galaxies rush toward each other, space contracts, matter compresses. Everything that is, stars, planets, dust, light, collapses inward. But toward what? What sits at the center of everything? Is it a singularity? A mathematical point of infinite density? Or something else entirely? Something beyond our current understanding? These aren't idle questions. They strike at the heart of existence itself. They force us to confront the limitations of human perception, the boundaries of knowledge. In this journey, we won't just explore the universe, we'll explore the edge of understanding itself. The universe is under no obligation to make sense to you. This isn't meant as discouragement, but as an invitation to shed preconceptions, to embrace the vertigo of cosmic scales and quantum uncertainties. To truly understand the core of the universe, we must first recognize how little we understand at all. Consider this. Every atom in your body was forged in the heart of a dying star. The iron in your blood, the calcium in your bones, cosmic debris recycled through generations of stellar life and death. You're not just in the universe is in you. This connection isn't metaphorical, it's literal. You're made of star stuff, a temporary arrangement of particles that have existed since the dawn of time. But those particles themselves, what are they? We speak of elementary particles as if they're tiny solid spheres, little billiard balls bouncing around. Yet quantum mechanics tells us they're more like vibrations in fields, probability waves that only collapse into definite positions when observed. Reality itself seems observer-dependent, raising profound questions about the nature of existence. Is the moon still there when no one is looking at it? Quantum mechanics doesn't give us a comfortable answer. And what of dark matter and dark energy, the invisible forces that make up 95% of our universe's content? We can't see them, can't touch them, can only infer their existence through their gravitational effects. Our visible reality, everything we can detect with our instruments, everything we can see with our eyes, is merely the surface of a much deeper cosmic ocean. The deeper we probe, the stranger things become. Time slows near massive objects. Space itself curves and bends. Empty space isn't empty at all, but roiling with virtual particles that pop in and out of existence. Particles can be entangled across vast distances, influencing each other instantaneously in ways that seem to violate the speed of light. These aren't science fiction concepts. They're established physics, backed by mountains of experimental evidence. Yet they remain profoundly counterintuitive, resistant to our attempts to visualize them, to fit them into our everyday experience of reality. Now imagine the core of it all, the heart of the universe, both its beginning and, perhaps, its end. If these relatively well-established phenomena already strain our comprehension, what mind-bending realities await us at the center? Some theories suggest that what we call the universe might be just one bubble in a vast multiverse, an endless sea of universes, each with different physical laws, different constants, different possibilities. Others propose that reality has more dimensions than the three spatial dimensions we perceive, with extra dimensions curled up so tightly that we can't detect them directly. String theory envisions fundamental particles not as points, but as tiny vibrating strings, each vibrating in different patterns to create the particles we observe. Loop quantum gravity suggests that space itself isn't continuous, but quantized, made up of tiny units, the atoms of space itself. These theories aren't just abstract mathematics, they're attempts to peer beyond the veil, to glimpse the machinery behind reality, and they all point to something profound. The universe is not only stranger than we imagine, it's stranger than we can imagine. You might be wondering why this matters. After all, whether the universe began with a bang or a whisper, whether reality has 10 dimensions or 4, doesn't change the price of bread or the daily commute. But this cosmic perspective changes something more fundamental. It changes us, our place in the grand scheme of things, our understanding of what it means to exist at all. When Copernicus placed the Sun, not Earth, at the center of the solar system, he didn't just change astronomy. He changed humanity's entire self-conception. We were no longer the center of creation, but inhabitants of one planet among many. Darwin's theory of evolution further displaced us from any special status, revealing us as one species among millions, the product of the same natural processes that shaped all life. Now we stand at the threshold of another revolution in understanding. Not just our planet, not just our species, but reality itself is turning out to be radically different from our intuitive pictures. What will this mean for how we see ourselves, our purpose, our place in the cosmos? Imagine standing at the edge of the Grand Canyon, feeling that vertiginous mix of awe and terror as you peer into the vastness. Now multiply that feeling by billions. That's the cosmic abyss we're peering into, not just spatially vast, but conceptually vast, challenging our most basic assumptions about existence. But there's something empowering in this cosmic perspective too. In all the immensity of space and time, here we are, conscious beings capable of contemplating the universe, of asking these profound questions. The universe has evolved complexity sufficient to contemplate itself. Through us, through our consciousness, the cosmos examines its own nature. As we journey toward the core, keep this in mind. We're not just passive observers, but active participants in the cosmic drama. Our quest to understand isn't separate from the universe. It's part of the universe's own evolution. The questions we ask, the theories we develop, the experiments we devise, these are the universe's way of understanding itself. This perspective transforms our cosmic isolation into connection. We're not insignificant motes in an indifferent cosmos. We're expressions of the cosmos itself, the means by which the universe achieves self-awareness. Our consciousness, our curiosity, our quest for meaning, these aren't accidents or side effects, but essential aspects of cosmic evolution. Now, let's return to that initial shock, the notion that the Big Bang wasn't what we thought. The term itself is misleading, coined somewhat mockingly by Fred Hoyle, who preferred a steady-state model of the universe. He meant it as a dismissive simplification, yet it stuck, giving generations the false impression of an explosion in pre-existing space. What really happened was far stranger. Space itself began to exist. Time began to tick. There was no outside for the universe to expand into. Space itself expanded, carrying galaxies along like raisins in rising bread dough. The early universe wasn't dark. It was blindingly bright, an opaque plasma so hot and dense that light couldn't travel freely. Only after about 380,000 years did the universe cool enough for electrons to bind with nuclei, forming the first atoms. At that moment, the moment of recombination, the universe became transparent, and light could travel freely for the first time. That ancient light is still traveling, cooled by cosmic expansion to just 2.7 degrees above absolute zero. We detect it as the cosmic microwave background radiation, the afterglow of creation itself. But even this more accurate picture doesn't capture the profound strangeness of the beginning. Our math breaks down as we approach time zero. Classical general relativity predicts a singularity, a point of infinite density, a cosmic punctuation mark where the equations themselves shatter. But we know general relativity is incomplete. It doesn't incorporate quantum mechanics, which must play a crucial role at such extreme scales. Some theories suggest the Big Bang wasn't the beginning at all, but a transition, perhaps a bounce from a previous contracting universe, perhaps the offspring of a parent universe, perhaps a quantum fluctuation in some pre-existing state. Others suggest that time itself might be an emergent property, not fundamental, arising from more basic quantum entanglements. These aren't just exotic speculations. They're serious scientific attempts to reconcile observations with mathematical consistency. They remind us that our current understanding is provisional, a work in progress. The map is not the territory, and our best theories are maps, useful but incomplete representations of an underlying reality that might be far stranger than we can currently conceive. Consider the horizon problem. Regions of the cosmic microwave, background that are too far apart to have ever been in causal contact, somehow have the same temperature. How could they have reached thermal equilibrium if they've never communicated with each other? Inflation theory proposes a solution, an incredibly rapid expansion in the universe's first fraction of a second. But what drove this inflation? What inflaton field possessed enough energy to stretch space at such incredible speeds? Or consider the flatness problem. Why is the universe's density so exquisitely balanced between eternal expansion and eventual collapse? If the initial density had differed by 1 part in 10 pxd from the critical value, the universe would have either collapsed immediately or expanded so quickly that no structures could form. That's a degree of fine-tuning that demands explanation. And what of the apparent accelerating expansion we observe today? Dark energy, a placeholder name for something we don't understand, seems to be pushing the universe apart at an increasing rate. Is this the same force that drove initial inflation? Is it a property of space itself? A fifth fundamental force? We don't know. The questions multiply, each answer breeding new mysteries. It's as if the universe is a vast puzzle box, each solved, compartment revealing 10 more locked chambers within. You might feel overwhelmed at this point. The scope of our ignorance can seem crushing. But consider another perspective. Each unanswered question is an opportunity, a frontier waiting to be explored. The history of science isn't a march toward final answers, but an ever-expanding sphere of wonder. As our knowledge grows, so does the surface area of our contact with the unknown. Isaac Asimov captured this beautifully. The most exciting phrase to hear in science, the one that heralds new discoveries, is not "Eureka!" but "That's funny." It's the anomalies, the discrepancies, the phenomena that don't fit our current understanding that drive progress. And what greater anomaly than the universe itself? Its existence is not self-explanatory. Whether you approach the question scientifically or philosophically, the brute fact of existence demands attention. Why is there something rather than nothing? This isn't just a scientific question, but a philosophical one, perhaps the philosophical question. Some modern theories suggest that nothing is unstable, that quantum fluctuations in empty space inevitably give rise to particles, to energy, to space-time itself. Others propose that all mathematically possible universes exist, with ours being just one realization among countless others. Still others suggest that the question itself might be malformed, presupposing concepts like causality that might not apply to existence as a whole. These aren't just abstract speculations. They cut to the heart of what reality is, what existence means. They force us to examine our most basic assumptions about being itself, and they return us to the central question: what lies at the core? Not just the physical core, the origin, point of the Big Bang, but the conceptual core, the heart of existence itself. What fundamental principle, what essence underwrites the cosmos? Is it mathematical? Many physicists have marveled at how mathematical the universe appears to be. Eugene Wigner wrote of the unreasonable effectiveness of mathematics in the natural sciences, the uncanny way that abstract mathematical structures, developed for their own sake, turn out to describe physical reality with astonishing precision. Is the universe fundamentally mathematical, with physical reality being a kind of shadow or implementation of deeper mathematical structures, or is it informational? Some theorists propose that information, not matter or energy, is the fundamental stuff of reality. In this view, particles and forces are manifestations of information processing at the quantum level. The universe isn't made of things, but of relations, of differences, of bits, or perhaps it's consciousness itself. The measurement problem in quantum mechanics, the way that observation seems to collapse probability waves into definite states, has led some to suggest that consciousness plays a fundamental role in reality. Is the universe, at its core, somehow mental rather than physical? These questions might seem to veer into metaphysics, beyond the reach of empirical science. But the history of physics is a history of metaphysical assumptions being brought into the realm of testable theories. What seems untestable today might be tomorrow's experimental frontier. As we contemplate these profound mysteries, remember that you are part of this cosmos, not separate from it. The atoms contemplating the universe are themselves products of the universe. There's something almost recursive about our quest. Matter organized into sufficient complexity to ask where matter came from. This brings us back to that initial shock, the realization that our most basic pictures of cosmic origins might be profoundly incomplete. The Big Bang, as commonly understood, is a simplification, a placeholder for a process far more complex and strange than a mere explosion. What if the truth is that there was no beginning at all? Some cyclic models propose an endless sequence of expansions and contractions, bangs and crunches, with no first cause necessary. Others suggest that what we perceive as the beginning might be a kind of illusion, a boundary of our knowledge rather than a boundary of existence itself. The ancient symbol of the Ouroboros, the serpent consuming its own tail, might be more apt than we realized. Perhaps the universe is somehow self-creating, self-sustaining, a closed causal loop with no external cause required. Perhaps questions of before and beginning are category errors when applied to the totality of existence. These possibilities don't diminish the grandeur of the cosmos. They enhance it. A universe that sprang fully formed from nothing is wondrous. A universe that somehow gives rise to itself is more wondrous still. A creation that requires a creator pushes the mystery back one step. A creation that is its own creator resolves the infinite regress. But these are speculations, educated guesses at best. The truth is that we don't know what lies at the core, not with certainty. And perhaps that's as it should be. Perhaps complete. Knowledge would rob existence of its mystery, its depth, its capacity to inspire awe. Think of it this way. The universe is not a problem to be solved, but a reality to be experienced. Our theories, our equations, our observations, these aren't the territory but maps, useful approximations of an underlying reality that transcends complete description. This doesn't mean surrendering to mysticism or abandoning the scientific project. Quite the opposite. It means approaching science with appropriate humility, recognizing the provisional nature of all knowledge while continuing to push the boundaries, to refine our understanding, to develop better maps, even while acknowledging that the territory itself might be inexhaustible. As we journey toward the core in subsequent sections, we'll examine specific theories in greater detail, weigh evidence, consider alternatives. We'll look at the empirical foundations for our current understanding and the frontiers where that understanding begins to fray. We'll explore the conceptual tools, from quantum field theory to string theory, from general relativity to loop quantum gravity, that we use to make sense of the cosmos. But throughout, keep this perspective in mind. The universe is not only more complex than we imagine, but more complex than we can imagine. Our cognitive apparatus evolved to track savanna predators and social alliances, not to intuit quantum fields or 11-dimensional manifolds. That we can approach these concepts at all, even indirectly through mathematics, is remarkable. There's something profound in this predicament. Creatures of the middle scale, neither cosmic nor quantum, striving to comprehend both. We exist at the interface between the immensely large and the infinitesimally small, between the age of the universe and the lifetime of subatomic particles. Perhaps this position isn't accidental, but necessary. Perhaps consciousness itself requires this middle ground, this balance point between extremes. If so, then our perspective, limited as it is, might still offer something unique, something valuable to the cosmic story. Not a God's eye view of totality, but a situated, embodied understanding that embraces its own partiality while continuing to reach beyond it. As we probe deeper, as we approach the core, both the physical core of cosmic origins and the conceptual core of existence itself, remember that the journey matters as much as the destination. The questions we ask, the wonder we feel, the community of inquiry we create, these aren't separate from cosmic understanding, but integral to it. The universe is not static, but evolving, not finished, but in process, And we are part of that process, not passive observers but active participants. Our consciousness, our curiosity, our quest for meaning, these aren't accidents but expressions of cosmic complexity, of the universe's own self-exploration. So as we confront the shock of our ignorance, as we question our most basic assumptions about cosmic origins, we do so not in despair, but in excitement. Each mystery is an invitation, each uncertainty a frontier. The cosmos is vaster, stranger, and more wondrous than we imagined, and that's cause for celebration, not concern. In the next section, we'll begin our deep dive into the evidence, the observations, measurements, and experiments that form the foundation of our current understanding. We'll examine the cosmic microwave background in detail, explore the distribution of galaxies across space, and consider what these patterns tell us about cosmic origins. We'll look at the abundance of elements in the universe and how their ratios support or challenge Big Bang cosmology. But before we do, take a moment to feel the weight of the question. What lies at the core? Not just intellectually, but emotionally, experientially. Let the vastness wash over you, the mystery envelop you. Recognize that in asking this question, in contemplating this abyss, you're engaging in one of the most profoundly human activities possible. You're participating in a tradition that stretches back to our earliest ancestors, who gazed at the night sky with wonder. They created myths, stories, cosmologies to make sense of what they saw. Our scientific cosmology is more mathematically sophisticated, more empirically grounded than these ancient stories, but it serves the same essential human need, the need to situate ourselves in the cosmos, to understand our place in the grand scheme of things. The details change, but the fundamental questions persist. Where did it all come from? Where is it all going? What does it mean to exist at all? These aren't just scientific questions, but existential ones. Questions that touch the core of our humanity, even as they probe the core of the cosmos. As we proceed, keep both perspectives in mind: the rigorous, empirical approach of science and the meaning-seeking, wonder-filled approach of human consciousness. Neither alone is sufficient. Together, they offer our best hope of approaching the core with both precision and reverence. The universe doesn't just exist. It exists for us, through us, as us. We are the means by which the cosmos contemplates itself, questions itself, wonders at itself. We are stardust become conscious, the universe looking back at itself in awe. And perhaps that, in the end, is what lies at the core. Not just physical processes, not just mathematical structures, but the potential for awareness, for wonder, for meaning. Perhaps consciousness itself, in all its forms throughout the cosmos, is not peripheral, but central to the cosmic story. This isn't to propose a return to an anthropocentric worldview. Quite the opposite. It's to recognize that consciousness, wherever and however it arises, is a cosmic phenomenon, as fundamental as gravity or electromagnetism. Not something outside the natural order, but an expression of that order's highest complexity. If so, then our quest to understand the core is itself part of what the core is, the universe's own self-inquiry, existence questioning its own nature. The seeker and the sought are not separate but aspects of a single process, a cosmic feedback loop of being and knowing. This perspective transforms the scientific project from a purely objective investigation of external reality to a participatory exploration in which we are both investigators and, in a sense, the investigated. Not in a solipsistic way that denies objective reality, but in a way that recognizes the inseparability of observer and observed at the deepest levels. Quantum mechanics has already forced us to confront this inseparability at the subatomic scale. Perhaps cosmology will lead us to a similar recognition at the largest scales, that the universe as we know it isn't independent of consciousness, but in some sense co-created with it, shaped by the questions we ask, the measurements we make, the concepts we employ. This doesn't mean the universe isn't really there, or that it's a mere mental construct. It means that the line between objective and subjective, between external and internal, might be less absolute than we've assumed. Reality might be neither purely objective nor purely subjective, but intersubjective, emerging from the interplay of consciousness and its objects. If this sounds radical, consider how radical quantum mechanics seemed to its early investigators. Niels Bohr remarked, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." Perhaps cosmology, when fully understood, will prove equally shocking to our conventional perspectives. So as we approach the core, we approach not just the heart of the physical cosmos, but the heart of the knowing process itself, the boundary where our maps meet the unmappable, where language and mathematics touch the ineffable. We approach the limit not just of our knowledge, but of knowledge as we currently conceive it. And that, perhaps, is the greatest shock of all. The realization that to truly understand the core, we might need to transform not just our theories, but our very mode of understanding, our epistemology, our conception of what knowledge itself is. The greatest revolutions in science haven't just added new facts, but changed how we think, how we see, how we know. From Galileo's telescope to Einstein's thought experiments to quantum indeterminacy, each breakthrough has expanded not just what we know, but how we know. Perhaps the next breakthrough will be equally transformative. Not just a new theory, but a new way of theorizing, not just new knowledge, but a new relationship to knowing itself. Perhaps the key to the core lies not in looking outward with ever more powerful instruments, but inward at the structure of consciousness that does the looking. This isn't to abandon empirical science, but to recognize its context, its embeddedness. In human experience, its dependence on concepts and categories that are themselves evolving. The most fundamental revolution might be not in what we see when we look at the universe, but in how we look, in the seeing itself. As we proceed with our exploration, keep this possibility in mind, that understanding the core might require not just new answers, but new questions, not just new theories, but new ways of theorizing, not just new knowledge, but new ways of knowing. The greatest discovery might be not some final theory of everything, but the recognition that reality is inexhaustible, that each answer opens new questions, that the cosmic conversation is endless. In this endless conversation, temporary certainties give way to deeper uncertainties, which in turn give way to new certainties at higher levels. The spiral continues, not toward some final endpoint, but as an ongoing process, an eternal dance of knowing and unknowing, of revelation and mystery. And perhaps that dance itself, that endless oscillation between comprehension and wonder, is the true nature of the core, the beating heart of existence. Not a static thing to be discovered once and for all, but a dynamic process to be participated in, a cosmic dialogue to be engaged with, a mystery to be lived. If so, then the journey we're undertaking isn't simply about getting answers, but about learning to ask better questions, questions worthy of the cosmos in all its complexity. It's about developing not just knowledge, but wisdom, the capacity to hold multiple perspectives, to embrace uncertainty, to find meaning in the quest itself rather than just its endpoints. This is the challenge and the invitation of the core, not merely to understand the universe, but to understand understanding itself. Not merely to know the cosmos, but to know ourselves as cosmic beings. Not merely to explain existence, but to participate in it more fully, more consciously, more reverently. Are you ready for this journey? Are you prepared to have your most basic assumptions challenged, your familiar concepts disrupted, your mental models transformed? Are you willing to approach the core not just with intellect, but with imagination, not just with analysis, but with awe? If so, then let's continue our exploration, not as passive recipients of established knowledge, but as active participants in the ongoing conversation between consciousness and cosmos, between the known and the unknown, between being and understanding. Let's approach the core not as something alien to us, but as our deepest nature, not as something out there, but as the ground of our own existence, the source from which we ourselves arise. The universe we think we know is built on pillars of light that has journeyed across billions of years to reach our instruments, our eyes, our understanding. When astronomers peer into the depths of space, tracing the choreography of distant galaxies, they're reading a story written in photons. It's a story most of us have accepted as settled science. A universe born in a hot, dense state that has been expanding for 13.8 billion years. A universe whose fundamental forces separated moments after its birth. A universe of dark energy and dark matter, of superclusters and voids, of black holes and neutron stars. This is our cosmic foundation, the model that has withstood decades of scrutiny, of testing, of refinement. But foundations can shift beneath our feet. What science calls the standard cosmological model is both a triumph and a mystery. It successfully explains so much: the abundance of light elements, the cosmic microwave background, the large-scale structure of galaxy distributions. Yet embedded within this success are paradoxes so profound they threaten to undermine the entire framework. We stand on what appears to be solid ground, unaware that beneath us lie chasms of uncertainty. Let's begin with what we think we know, not to recite textbook cosmology, but to feel the weight of it, to see it not as abstract mathematics, but as a vast, unfolding drama. Imagine yourself as a cosmic observer, freed from the constraints of time, watching the universe rewind. Galaxies rush toward each other, space contracts, everything becomes hotter, denser. About 380,000 years after the beginning, you'd witness a moment of profound transition, the moment when the universe cooled enough for electrons to bind with protons, forming the first atoms. Before this moment, the universe was opaque, a blazing fog of charged particles scattering photons in every direction. After this moment, light could travel freely for the first time. This first light still surrounds us, the cosmic microwave background radiation, the oldest light in the universe. When we detect it with our instruments, we're sensing the surface of an impossibly ancient sphere, a shell of radiation that has been expanding outward for 13.8 billion years. It's as close as we can come to seeing the Big Bang itself, or so we thought. The cosmic microwave background isn't just an echo of creation. It's a map of tiny temperature variations, quantum fluctuations stretched to cosmic scales by the universe's expansion. These minute differences, just one part in 100,000, were the seeds that would eventually grow into galaxy clusters, into the vast cosmic web that structures our universe. Their pattern tells us about the composition of the early universe, about the dark matter that guided the formation of structure, about the dark energy that now accelerates cosmic expansion. But there's something strange about this pattern, something that doesn't quite fit our expectations. The fluctuations are too uniform across the sky. Regions that should never have been in causal contact, that should never have been able to communicate with each other due to the finite speed of light, somehow reached the same temperature, It's as if you found two people on opposite sides of the Earth who had never met, never communicated, yet were telling identical stories down to the smallest detail. This is the horizon problem, one of several anomalies that led to the theory of cosmic inflation. According to inflation theory, the early universe underwent a period of exponential expansion, increasing in size by a factor of at least 10^26 in just 10^32 seconds. This mind-bending growth spurt would have taken regions that were once in close contact and flung them to opposite sides of the observable universe, explaining their similar properties. Inflation is now a cornerstone of modern cosmology, solving not just the horizon problem, but also explaining why the universe appears so geometrically flat and why we don't observe magnetic monopoles that should have been produced in the early universe. Yet inflation itself raises profound questions. What caused it? What field or force could contain enough energy to drive such explosive expansion? And why did it start and stop when it did? The inflation field postulated to drive inflation has never been directly detected. It remains a theoretical necessity rather than an empirical certainty. And here we encounter our first unraveling. A theory invented to solve problems in our understanding may itself be nothing more than a mathematical convenience, a placeholder for processes we don't yet comprehend. What if inflation is just a beautiful story we tell ourselves to paper over the cracks in our cosmic narrative? Some cosmologists have proposed alternatives, varying speed of light theories, cyclic models, entropic scenarios that don't require inflation. Others suggest that inflation itself might be more complex than initially thought, occurring in patches, creating a multiverse of distinct cosmic regions with different properties. The solid ground begins to shift beneath our feet. Now, let's move forward in cosmic time to the formation of structure, the emergence of the cosmic web that forms the universe's scaffolding. Here, too, what once seemed straightforward becomes increasingly complex the closer we look. Dark matter, invisible, mysterious, detectable only through its gravitational effects, supposedly guides this process, drawing ordinary matter into its gravitational wells, seeding the formation of galaxies. We've mapped its distribution through gravitational lensing, through the rotation curves of galaxies, through the dynamics of galaxy clusters. The evidence for its existence is overwhelming. And yet, despite decades of searching, no dark matter particle has ever been directly detected. Our most sensitive experiments, deep underground detectors shielded from cosmic rays, powerful particle accelerators smashing protons together at nearly the speed of light, have found nothing. The candidates keep shifting, from massive neutrinos to axions, from weakly interacting massive particles to primordial black holes. Each failure to detect forces, new theoretical contortions. What if dark matter doesn't exist at all? What if it's a phantom, a misinterpretation of gravity itself? Modified Newtonian dynamics, MOND, and its relativistic extensions suggest that gravity might behave differently at galactic scales than our current theories predict. These alternatives have their own problems, but they remind us that even the most established pillars of our cosmological model might be mirages. The universe isn't just expanding, it's accelerating in its expansion, pushed apart by some mysterious dark energy that permeates empty space. This acceleration, discovered in 1998 by measuring the brightness of distant supernovae, came as a shock to the scientific community. It suggested that about 68% of the universe's energy content consists of something completely unknown, something that acts as a kind of anti-gravity, pushing galaxies apart faster and faster as cosmic time progresses. The simplest explanation is that dark energy is the energy of empty space itself. what physicists call vacuum energy, or the cosmological constant. But when we try to calculate how much energy empty space should contain according to quantum field theory, we get a value that's wrong by 120 orders of magnitude, perhaps the most dramatic disagreement between theory and observation in the history of science. Imagine being off in your prediction, not by a factor of 2 or 10 or even a million, but by a factor with 120 zeros after it. It's as if you tried to guess someone's height and were off by the size of the observable universe. This isn't just a small discrepancy, it's a fundamental failure of our understanding. Some theorists propose dynamic dark energy models, where the energy density changes over time. Others suggest modifications to Einstein's theory of gravity at cosmic scales. Still others wonder if the accelerating expansion is an illusion, a misinterpretation of our position in a vast cosmic structure, a kind of gigantic bubble in the high cosmic foam. The universe we thought we knew is dissolving before our eyes, transforming from a solved equation into an open question. And we haven't even touched the most profound mysteries yet. At the very beginning, during the first microsecond of cosmic existence, the extreme temperatures and densities would have produced conditions where quantum gravity becomes unavoidable, where Einstein's theory of general relativity, which describes gravity as the curvature of spacetime, collides with quantum mechanics, which governs the behavior of matter and energy at the smallest scales. These two pillars of modern physics, each extraordinarily successful in its domain, become incompatible in the inferno of the Big Bang. General relativity treats spacetime as smooth and continuous. Quantum mechanics suggests it might be granular at the smallest scales. General relativity is deterministic. Quantum mechanics is probabilistic. The equations break down, the mathematics fails, our understanding reaches its limit. This isn't just a technical problem for physicists, it's a conceptual abyss at the heart of our cosmic story. If we can't reconcile these frameworks, we can't truly understand cosmic origins. We're like readers who discover that the first chapter of a book is written in an indecipherable language. We can follow the story from chapter 2 onward, but the beginning, the foundation, remains obscure. String theory proposes that the fundamental constituents of reality aren't point-like particles, but tiny vibrating strings, whose different modes of vibration produce the particles we observe. In this framework, gravity emerges naturally alongside the other fundamental forces. But string theory requires extra spatial dimensions beyond the three we experience. Dimensions curled up so tightly that we don't notice them in everyday life. Loopy. Quantum gravity suggests that space itself isn't continuous but quantized, made up of discrete units at the smallest scales, like pixels in a digital image. In this view, spacetime is a kind of quantum foam, a seething network of relationships between elementary grains of space. These approaches, and others, struggle with the same fundamental question. What is space itself? Is it a thing, a substance, a field? Or is it merely a relationship between things, a way of describing how entities are connected? Is time a dimension like space? Or is it something more fundamental, the substrate in which change occurs? The early universe wasn't just hot. It was a furnace where time itself was still learning to flow, where space was still figuring out how to be. Try to imagine this. Not just matter in an extreme state, but reality itself in formation. The laws of physics crystallizing out of more fundamental principles we haven't yet grasped. This isn't poetry. It's the frontier of theoretical physics. The notion that the laws of physics themselves might evolve, might emerge from deeper principles, is gaining traction among serious researchers. What we experience as immutable natural laws might be the frozen accidents of cosmic evolution, the particular configuration that took hold in our observable patch of the multiverse. The multiverse itself, the idea that our universe might be just one bubble in an infinite cosmic foam, emerges naturally from inflation theory. If inflation can happen once, it can happen repeatedly, spawning new universes with potentially different physical laws, different constants, different possibilities. Our cosmic horizon, the limit of what we can observe, might be just one facet of a much larger, perhaps infinite reality. This isn't just abstract speculation. It's a serious attempt to explain why our universe appears so exquisitely fine-tuned for the emergence of complexity, of stars, of life. The physical constants, like the strength of gravity, the mass of the electron, the energy of the vacuum, seem calibrated with impossible precision to allow for our existence. Change any one of them slightly, and stars couldn't form. Atoms couldn't assemble. Complexity couldn't emerge. Is this evidence of design, of purpose? Or is it simply selection bias? We can only observe universes compatible with our existence. In a vast multiverse with varying laws and constants, we necessarily find ourselves in a region where complexity can emerge, just as fish necessarily find themselves in water rather than on land. These questions blur the boundary between physics and philosophy, between empirical science and metaphysical speculation. Yet, they arise naturally from our best theories, from our attempts to build a coherent picture of cosmic evolution. And now we arrive at an even deeper mystery: the arrow of time itself. The fundamental laws of physics, whether classical or quantum, are largely time-symmetric. Run the equations backward, and they still work. Yet we experience an obvious asymmetry. Eggs break, but don't unbreak. Coffee cools, but doesn't spontaneously heat up. We remember the past, but not the future. This one-way flow, this irreversibility, is embodied in the second law of thermodynamics. In closed systems, entropy, roughly the measure of disorder, always increases over time. But why? What gives time its arrow? And was this arrow present at the beginning, or did it emerge later? Some theorists suggest that the arrow of time isn't fundamental but emergent, a consequence of the universe's initial state having extraordinarily low entropy. The universe began in a highly ordered state, though this might seem counterintuitive given the extreme temperatures and densities, and has been running down ever since, increasing in disorder as it expands and cools. But this just pushes the question back. Why did the universe begin in such an unlikely, low-entropy state? Roger Penrose has calculated that the odds against such a state occurring by chance are so astronomically large that they make winning the lottery every day for 1 billion years seem probable by comparison. Perhaps the arrow of time isn't universal, but local, varying across the multiverse. Perhaps in some regions, entropy decreases rather than increases. Perhaps past and future are more fluid, more interchangeable than our everyday experience suggests. Or perhaps the arrow of time is more fundamental than we've recognized. Not an emergent property, but a basic feature of reality, as essential as space or energy. Perhaps time's flow isn't an illusion or a psychological construct, but the most real thing there is, the current that carries all existence forward. These aren't just academic questions. They cut to the heart of what it means for anything to exist at all, what it means for events to happen, for processes to unfold, for complexity to emerge, for life to evolve, for consciousness to witness it all. And here we encounter one of the deepest paradoxes. The universe appears to have evolved from simplicity to complexity, from homogeneity to structure, from hydrogen clouds to thinking beings. Yet the second law of thermodynamics tells us that closed systems evolve toward greater disorder, not greater order. Life, consciousness, culture. These seem to run counter to entropy's tide, creating pockets of increasing order and complexity. In a universe supposedly running down toward heat death, how is this possible? The answer lies in understanding that local decreases in entropy are possible at the expense of greater increases elsewhere. Living systems maintain their order by exporting entropy to their surroundings. Earth's biosphere is an open system, powered by the sun's energy. The sun itself is running down, converting mass to energy in its core, increasing the universe's overall entropy, even as it powers the emergence of complexity here. But this local perspective doesn't resolve the larger paradox. Why should a universe governed by entropy's increase give rise to complexity at all? Why should mindless physical laws, playing out over billions of years, produce beings capable of understanding those laws, of asking these questions, of seeking meaning in the cosmic process? Some theorists propose that complexity and consciousness aren't accidental byproducts but inevitable emergent properties of physical systems under certain conditions. Information processing, they suggest, naturally evolves toward greater complexity, toward systems that model their environments with increasing sophistication. Others wonder if consciousness itself might be fundamental rather than emergent, either basic feature of reality rather than a late-arriving complexity. Panpsychism suggests that even elementary particles might possess some form of proto-consciousness, some rudimentary subjectivity that becomes more complex, more integrated as matter organizes itself into brains and nervous systems. These ideas remain speculative, controversial, at the boundaries of what science can currently address. Yet they arise naturally from our cosmological model, from our attempts to understand not just what the universe is, but why it is the way it is. And they return us to the central question: what lies at the core? Not just the physical core, the origin point of the Big Bang, but the conceptual core, the heart of existence itself. What fundamental principle, what essence underwrites the cosmos? Is it mathematical? Many physicists have marveled at how mathematical the universe appears to be. Eugene Wigner wrote of the unreasonable effectiveness of mathematics in the natural sciences, the uncanny way that abstract mathematical structures, developed for their own sake, turn out to describe physical reality with astonishing precision. Is the universe fundamentally mathematical, with physical reality being a kind of shadow or implementation of deeper mathematical structures? This view, known as mathematical Platonism, suggests that mathematical objects aren't human inventions, but discoveries that they exist independently of minds in some abstract realm. The Mandelbrot set, with its infinite complexity emerging from a simple recursive equation, wasn't created by Benoit Mandelbrot, but discovered by him. It was there all along, waiting to be found. If true, this perspective transforms our understanding of reality itself. The universe isn't made of stuff that happens to follow mathematical rules. It is those rules, those patterns, those relationships. Matter, energy, space-time. These are manifestations of deeper mathematical structures, not the other way around. Max Tegmark has taken this idea to its logical conclusion with his mathematical universe hypothesis, suggesting that reality itself is a mathematical structure. In this view, the challenge isn't to explain why the universe is mathematical, but why it seems physical at all. Why we experience math as matter, as energy, as space and time. Or perhaps the core isn't mathematical, but informational. Some theorists propose that information, not matter or energy, is the fundamental stuff of reality. In this view, particles and forces are manifestations of information processing at the quantum level. The universe isn't made of things, but of bits, of differences, of distinctions. This informational perspective aligns with quantum mechanics, where particles don't have definite properties until those properties are measured, where reality seems to crystallize out of probability waves when information is extracted from the system. It suggests that what exists isn't objects with intrinsic properties, but relationships, differences that make a difference. John Wheeler captured this view in his phrase, "it from bit," the notion that the physical emerges from the informational, that the tangible world arises from abstract differences. In this framework, black holes aren't just extreme gravitational phenomena, but information processors, quantum computers operating at the boundary of space-time itself. These perspectives, mathematical, informational, might seem abstract, detached from everyday experience, but they're attempts to get at the most fundamental level of reality, to penetrate the veil of appearances and glimpse the machinery behind, and they lead to a profound realization. What we call fundamental might itself be relative to our perspective, to our level of description. What seems elementary at one scale might be composite at another. What appears simple from one angle might reveal vast complexity from another. Consider water. To our everyday experience, it's a fundamental substance, a basic element of our world. To a chemist, it's a compound of hydrogen and oxygen, molecules formed from atomic bonds. To a nuclear physicist, it's a complex arrangement of protons, neutrons, and electrons, themselves composed of quarks and gluons. At each level, new properties emerge that weren't present at the level below. Wetness, surface tension, viscosity aren't properties of individual water molecules, but emerge from their collective behavior. The same principle might apply to reality as a whole. What we consider fundamental physics, quantum fields, space-time, the standard model particles, might be emergent phenomena arising from deeper structures we haven't yet glimpsed. String theory suggests as much, proposing that the particles we observe are vibration modes of more fundamental strings. Loop quantum gravity suggests that space-time itself emerges from networks of more basic quantum gravitational relationships. This hierarchy might extend indefinitely, each rock bottom revealing new depths beneath. There might be no final theory, no ultimate level of description, just an endless series of models, each more comprehensive than the last, but none exhaustive. Or there might be a limit to this descent, a fundamental level beyond which reality cannot be further decomposed. Perhaps there is a core, a foundation, a ground of being that supports all existence. But this core might not be what we expect. Not a particle, not a field, not even a mathematical structure, but something more fundamental still. Perhaps consciousness itself lies at the core. The measurement problem in quantum mechanics, the ivory way that observation seems to collapse probability waves into definite states, has led some to suggest that consciousness plays a fundamental role in reality. In this view, the universe isn't purely physical or purely mental, but a kind of psychophysical unity, a reality in which consciousness and matter are two aspects of the same underlying process. This isn't to propose a return to an anthropocentric worldview. Quite the opposite. It's to recognize that consciousness, wherever and however it arises, is a cosmic phenomenon, as fundamental as gravity or electromagnetism, not something outside the natural order, but an expression of that order's highest complexity. If so, then our quest to understand the core is itself part of what the core is, the universe's own self-inquiry, existence questioning its own nature. The seeker and the sought are not separate, but aspects of a single process, a cosmic feedback loop of being and knowing. This perspective transforms the scientific project from a purely objective investigation of external reality to a participatory exploration in which we are both investigators and, in a sense, the investigated. Not in a solipsistic way that denies objective reality, but in a way that recognizes the inseparability of observer and observed at the deepest levels. But let's step back from these philosophical depths and return to the empirical foundation. What does the evidence actually tell us about the universe's birth, about the conditions at the beginning, about what might have preceded the Big Bang, if anything? The cosmic microwave background radiation gives us a snapshot of the universe. At 380,000 years after the beginning, the earliest direct observation we can make. Before that, the universe was opaque to electromagnetic radiation. To probe earlier times, we need other messengers. Gravitational waves, ripples in space-time itself, offer one possibility. Unlike light, they can travel through the opaque early universe, potentially carrying information from the first fraction of a second after the Big Bang. Advanced detectors like LIGO and Virgo have already observed gravitational waves from colliding black holes and neutron stars. Future space-based detectors might be sensitive enough to detect the faint echoes of creation itself. Neutrinos, nearly massless particles that rarely interact with ordinary matter, might also carry information from the early universe. The cosmic neutrino background, analogous to the cosmic microwave background but much harder to detect, would give us a picture of the universe just 1 second after the Big Bang. Even more exotic messengers are theoretically possible. Magnetic monopoles, hypothetical particles carrying a single magnetic pole, might have been produced in the extreme conditions of the early universe. Cosmic strings, one-dimensional defects in space-time, could also bear witness to the moment of creation. But all these potential messengers, even if detected, would still tell us only about the universe after the Big Bang. What about before? Was there a before? Could time itself have had a beginning, or does it stretch backward indefinitely? Classical general relativity predicts a singularity at the beginning, a point of infinite density where space-time itself breaks down. But this prediction is likely an artifact of the theory's limits rather than a physical reality. Quantum effects, which general relativity doesn't incorporate, almost certainly become dominant at such extreme scales, preventing a true singularity from forming. Various proposals attempt to describe what might have happened instead. Quantum cosmology suggests that the universe might have emerged from a quantum tunneling event, a kind of phase transition from one state to another. Loop quantum cosmology proposes a big bounce rather than a big bang, a universe that contracts to a minimum size and then rebounds with quantum gravitational effects preventing a singularity. String theory offers the possibility of brane cosmology, where our universe exists as a three-dimensional brane in a higher dimensional space. The Big Bang might have been the result of a collision between our brane and another, transferring energy that initiated our cosmic expansion. These models are speculative, tentative, at the frontier of theoretical physics. They're attempts to push our understanding beyond current limits, to peer through the veil of the Big Bang and glimpse what might lie beyond. They remind us that our current cosmological model, successful as it is in many respects, is incomplete, a work in progress, not a final answer. And this brings us to a profound realization. The universe isn't a solved equation, but an ongoing investigation. Not a closed book, but an unfolding story. Each answer breeds new questions. Each discovery opens new horizons. The cosmos isn't just expanding physically. Our understanding of it is expanding conceptually. This isn't a failure of science, but its greatest strength, the capacity to evolve, to incorporate new evidence, to refine its models, to acknowledge its limitations. The standard cosmological model isn't wrong so much as incomplete, an approximation that works remarkably well within certain bounds, but breaks down at the extremes. And those extremes, the beginning of time, the edge of space, the heart of a black hole, are precisely where the deepest mysteries lie, where our current understanding reaches its limits, where new physics must emerge. Consider black holes, regions where gravity becomes so intense that nothing, not even light, can escape. According to general relativity, at the center of a black hole lies a singularity, a point of infinite density where space-time curves infinitely. But this can't be the whole story. Quantum effects must become important near the singularity, modifying the classical picture in ways we don't yet fully understand. What happens to information that falls into a black hole? Quantum mechanics suggests that information can't be destroyed, yet black holes seem to erase it completely. This information paradox has led to heated debates among physicists, with proposed resolutions ranging from subtle quantum effects at the event horizon to exotic structures like firewalls or fuzzballs that replace the classical black hole interior. These aren't just technical issues but profound conceptual challenges that force us to reconsider our most basic assumptions about reality. If information is truly fundamental, as some theories suggest, then its apparent destruction in black holes challenges our entire framework. If space-time itself emerges from deeper quantum gravitational structures, as other theories propose, then the interior of a black hole might be where this emergence breaks down, where the fabric of reality unravels. Black holes might be more than extreme astrophysical objects. They might be windows into the fundamental nature of existence, places where the universe reveals its deepest secrets, and they might be connected to the Big Bang itself, to the origin of our cosmos. Some theorists propose that our universe might have been born from the interior of a black hole in another universe, a kind of cosmic reproduction. Others suggest that the Big Bang and black hole singularities are different aspects of the same phenomenon, points where our current understanding breaks down in similar ways. These speculations remind us that the boundaries of our knowledge are not fixed but expanding, that what seems impossible or incomprehensible today might become the foundation of tomorrow's understanding. The history of science is a history of conceptual revolutions, of paradigm shifts that transform not just what we know, but how we know. And perhaps the greatest paradigm shift would be the recognition that reality isn't just what we observe, but how we observe it. That consciousness itself isn't incidental to the cosmic story, but integral to it. Not in a mystical or supernatural sense, but in the sense that the universe isn't just stuff, but also perspective. Not just being, but also knowing. This doesn't mean abandoning objectivity or empirical science. Quite the opposite. It means recognizing that objectivity itself is a perspective, a way of knowing that has proven extraordinarily powerful, but is not the only way, not the complete story. The view from nowhere is still a view from somewhere. The universe doesn't just exist, it exists for us, through us, as us. We are the means by which the cosmos contemplates itself, questions itself, wonders at itself. We are stardust become conscious, the universe looking back at itself in awe. And perhaps that, in the end, is what lies at the core. Not just physical processes, not just mathematical structures, but the potential for awareness, for wonder, for meaning. Perhaps consciousness itself, in all its forms throughout the cosmos, is not peripheral, but central to the cosmic story. If the universe has no edge, then where does it begin? This paradox isn't just a play on words, but a profound conceptual challenge. Our intuition tells us that anything finite must have a boundary, an edge where it stops. But the universe might be finite yet boundless, like the surface of a sphere. Finite in area, but with no edge, no boundary, no outside. A two-dimensional being living on the surface of a sphere would experience a finite yet boundless universe. They could travel indefinitely in any direction, without ever reaching an edge. Their space would curve back on itself, creating the illusion of infinite extent despite being finite in actual area. Our three-dimensional space might have an analogous property, curving in a higher dimension to create a closed, finite volume. With no boundary, the universe wouldn't have an edge where it stops. It would simply close back on itself like a hypersphere, the three-dimensional analog of a sphere's surface. This possibility raises profound questions about the nature of space itself. Is space a thing, a substance that exists independently of what it contains? Or is it merely a relationship between things, a way of describing how entities are connected to each other? Is it absolute or relative, fundamental or emergent? Einstein's theory of general relativity suggests that space isn't an inert background against which cosmic events play out, but an active participant in those events, bending and warping in response to mass and energy. Space tells matter how to move. Matter tells space how to curve. This dynamic relationship transforms space from a static container into an evolving, responsive entity. But this classical picture, powerful as it is, breaks down at the quantum scale, where space itself might be granular, discrete, composed of fundamental units rather than infinitely divisible. At the Planck scale, about 10^35 meters, space might lose its smooth continuity, fragmenting into a quantum foam of fluctuating geometry. These are not abstract cosmological questions. They're investigations into the nature of reality itself. What does it mean to inhabit a universe that may be bounded in volume yet infinite in its internal geography? How does a space-time that can bend, ripple, and even tear back on itself through wormholes change our conception of what space fundamentally is? And perhaps most profound of all, what does it mean that our measly three dimensions might be embedded in a higher dimensional bulk, as suggested by certain versions of string theory and brain cosmology? What are the other dimensions doing? Are they infinitesimally small, curled up into complex geometric shapes called Calabi-Yau manifolds? Or could they be vast, even infinite, with our three-dimensional universe merely a membrane floating in a higher dimensional sea? In the realm of cosmic expansion, we often hear the glib shorthand that there's no center to the expansion, no special point from which everything is moving away. But let's really contemplate what this means, if there's truly no center to the cosmic expansion. Then, in a profound sense, everywhere is the center. Every galaxy, every planet, every speck of cosmic dust experiences the universe as if it were the focal point from which all else recedes. This isn't an illusion. It's a fundamental property of how space itself expands. The expansion doesn't happen in space. It happens to space. The distance between galaxies increases not because galaxies are moving through static space, but because space itself is stretching, carrying galaxies along like raisins in rising bread dough. The early universe wasn't just a smaller version of today's cosmos. It was a fundamentally different reality, hotter, denser, governed by physics we can only partially reconstruct. The four fundamental forces that we know today, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were unified at high energies, indistinguishable aspects of a single interaction. As the universe expanded and cooled, these forces separated, freezing out from their unified state in a series of phase transitions analogous to water freezing into ice. Except these cosmic phase transitions didn't just change the state of matter, but the laws governing matter itself. The early universe wasn't just hot, it was a furnace where time itself was still learning to flow, where space was still figuring out how to be. This isn't poetic license, it's a description of a cosmos where the distinction between space and time was blurred, where the arrow of time itself might have emerged from more symmetric beginnings. And when we look at our cosmic horizon, the limit of what we can observe, we're not seeing the edge of the universe, but the edge of the observable universe, the boundary beyond which light hasn't had time to reach us since the Big Bang. The actual universe almost certainly extends far beyond this horizon, perhaps infinitely far. What lies beyond our cosmic horizon isn't empty space, but more universe, more galaxies, more stars, perhaps even regions with different physical laws, different constants, different possibilities. This vast, perhaps infinite expanse transforms our cosmic perspective. Our observable universe, already so immense that it strains comprehension, might be an infinitesimal fraction of what exists. We might be like microbes in a drop of water, unaware of the ocean that surrounds us. And if inflation theory is correct, this ocean might contain countless other drops, other pocket universes nucleating like bubbles in boiling water, each with its own physical laws, its own constants, its own possibilities. Our universe might be just one bubble in an infinite cosmic foam, one facet of a multiverse so vast that it makes our observable cosmos seem like a grain of sand on an endless beach. This perspective transforms our understanding of fine-tuning. The puzzling fact that the physical constants of our universe seem exquisitely calibrated for the emergence of complexity, of stars, of life. If a vast or infinite multiverse exists, with varying laws and constants, then regions hospitable to life will inevitably exist somewhere. And it's no surprise that we find ourselves in such a region. We couldn't exist in the vast majority of the multiverse where different constants prevent atoms from forming, stars from shining, complexity from emerging. But this resolution raises its own profound questions. If the multiverse is real, is it testable? Can we detect the influence of other bubble universes on our own? Are there signatures of cosmic collisions imprinted on our cosmic microwave background? Some theorists think so, while others worry that the multiverse concept risks becoming unfalsifiable, slipping from science into speculation. These questions blur the boundary between physics and philosophy, between empirical science and metaphysical reflection. Yet, they arise naturally from our best theories, from the mathematical descriptions that have proven so successful in explaining what we observe. And they return us to the central paradox, a universe that appears to have a beginning but no edge, that seems finite in time but possibly infinite in space, that follows mathematical laws, yet contains beings capable of discovering those laws, of asking why they are as they are. If the universe truly has no edge, then in a profound sense, everything is the center. Every point is as fundamental as every other. And if the universe truly had a beginning, then in an equally profound sense, every moment contains that beginning. The originating event isn't just in the distant past, but woven into the fabric of the present, into the laws and constants that govern every interaction, every process, every thought. The cosmic drama isn't something that happened long ago and far away. It's happening here, now, within us and around us. The heat of the Big Bang resonates in every atomic nucleus. The expansion of space continues in every cubic centimeter. The phase transitions that shaped the fundamental forces echo in every interaction between particles. We don't stand outside this cosmic process, observing it from some privileged vantage point. We're immersed in it, constituted by it, expressions of its possibilities. Our atoms were forged in stellar furnaces. Our elements were scattered by supernovae. Our molecules assembled according to chemical principles that emerge. What lives at the cosmic crossroads where our understanding breaks down? Where mathematics collapses? Where physics fails? where reality itself seems to tear at the seams. This is the territory we now enter, not as casual tourists, but as investigators of the deepest mysteries in existence. The stakes couldn't be higher. At the core of these paradoxes lies not just the fate of our universe, but the nature of reality itself. We're about to journey into regions where even our most brilliant minds have been humbled. The singularity, quantum gravity, the arrow of time, the multiverse. These aren't just abstract concepts. They are the frontier where humanity's understanding of existence is being rewritten in real time. Let's begin with what might be the most profound mystery: the singularity, a word that sounds clinical, mathematical, almost innocuous. But in cosmology, a singularity represents nothing less than the complete breakdown of physical law, a cosmic dead end where our equations shatter against the wall of the unknowable. In the traditional Big Bang model, when we trace cosmic history backward, everything converges to a point of infinite density, infinite temperature, infinite curvature of spacetime, a mathematical point where the laws of physics as we understand them simply cease to function. Einstein's general relativity, our best description of gravity and spacetime, predicts its own failure at this boundary. The equations literally break down, producing infinities that have no physical meaning. Imagine reality as a film reel, where each frame represents a moment in cosmic evolution. As we move backward through the frames, galaxies get closer together. Everything becomes hotter and denser. But when we try to find the first frame, the absolute beginning, we discover that the film itself has melted, leaving nothing but an indecipherable smear. The singularity isn't just another frame on our cosmic film, it's the dissolution of the medium itself. This isn't just a problem of missing information or inadequate instruments, it's more fundamental. Our entire conceptual framework collapses at the singularity. Space and time themselves lose meaning. Cause and effect become scrambled beyond recognition. The very notion of before becomes problematic when time itself is born at this boundary. But most physicists don't believe the singularity is physically real. It's more likely a sign that our theories are incomplete, that we're missing something essential about how reality works at the most fundamental level. Just as Newtonian physics broke down at speeds approaching light or in strong gravitational fields, requiring Einstein's relativity, so general relativity itself breaks down near the singularity, requiring a deeper theory, a quantum theory of gravity. The hunt for this elusive theory has consumed theoretical physics for nearly a century. It's not just an academic puzzle. It's our best hope for understanding what happened at the birth of our universe, or whether birth is even the right concept at all. The current leading approaches, string theory and loop quantum gravity, offer radically different visions of what might replace the singularity, of what might have happened before the Big Bang, if before even makes sense in this context. String theory proposes that the fundamental constituents of reality aren't point-like particles, but tiny vibrating strings, whose different modes of vibration produce the particles we observe. In this framework, the singularity gets smoothed out, replaced by more exotic processes involving the creation of our universe as a brane, short for membrane, in a higher dimensional space. One intriguing string theory scenario suggests our universe began when two such branes collided in a higher dimensional bulk. The energy of this collision manifested as the hot, dense plasma of the early universe, what we interpret as the Big Bang. In this picture, our cosmos might be just one episode in a much larger cosmic drama, a cycle of collisions and separation, playing out in dimensions we can't directly perceive. Loop quantum gravity, meanwhile, offers an entirely different resolution. It suggests that spacetime itself isn't continuous but quantized, made up of discrete units at the smallest scales, like pixels in a digital image. These fundamental building blocks, atoms of space, have a minimum size, preventing the infinite compression that would create a true singularity. In the loop quantum cosmology model, the universe didn't begin from a singularity, but underwent a big bounce, contracting to a minimum size determined by quantum effects, then rebounding into expansion. Our universe's expansion might be just the latest phase in an eternal cycle of contraction and expansion with no absolute beginning and no final end. These aren't just idle speculations. They're serious attempts to reconcile quantum mechanics and general relativity, to create a coherent framework that works at all scales, from the subatomic to the cosmic. And they raise profound questions about the nature of time, about cosmic origins, about what it means for something to begin at all. The mathematician Roger Penrose has proposed yet another alternative: conformal cyclic cosmology. In this model, the remote future of one universe becomes the Big Bang of the next. As matter decays over inconceivably long timescales and black holes evaporate, a universe approaches a state where distances become meaningless, effectively resetting the cosmic clock. Yesterday's eternity becomes tomorrow's first instant. What's remarkable about these different approaches isn't just their technical ingenuity, but their philosophical implications. They transform our conception of cosmic history from a linear progression with a definite beginning to something more complex: a cycle, a branching tree, a section of a larger continuum. And they force us to confront the limitations of our most basic concepts. What does beginning mean when time itself is part of what's coming into existence? What does before mean when the arrow of time reverses, loops back on itself, or emerges from more fundamental quantum relationships? These questions aren't just semantic puzzles. They cut to the heart of how we understand reality itself. They suggest that our most basic intuitions about existence, that things either are or aren't, that causes precede effects, that the past is fixed while the future is open, might be provisional, valid in certain contexts, but breaking down at the deepest levels. Now, let's take another path into the cosmic labyrinth: quantum gravity, the elusive theory that would unite quantum mechanics and general relativity. These two pillars of modern physics, each extraordinarily successful in its domain, seem fundamentally incompatible. General relativity describes gravity as the curvature of smooth, continuous spacetime. Quantum mechanics suggests that at the smallest scales, reality is granular, probabilistic, governed by uncertainty. The conflict comes to a head in regions of extreme density and energy, the center of a black hole, the first fraction of a second after the Big Bang. In these environments, both quantum effects and gravitational effects become crucial, yet our current theories can't handle their intersection. It's as if we have two partial maps of reality, each exquisitely detailed in its region, but with a terra incognita where they should overlap. Different approaches to quantum gravity represent different attempts to fill in this blank area, to create a unified map that preserves the essential insights of both quantum mechanics and general relativity while transcending their limitations. String theory, which we've already encountered, is one such attempt. It suggests that the fundamental constituents of reality aren't point-like particles, but tiny vibrating strings whose different modes of vibration produce the particles we observe. These strings exist in a higher dimensional space, with the extra dimensions curled up so tightly that we don't notice them in everyday life. In the string theory framework, gravity emerges naturally alongside the other fundamental forces. The graviton, the hypothetical particle that mediates the gravitational force, corresponds to a particular vibration mode of the string. The infinities that plague attempts to quantize gravity using conventional methods are naturally smoothed out by the extended nature of strings, which can't be compressed to a point. But string theory comes with its own challenges. It requires extra spatial dimensions beyond the three we experience. It encompasses not one, but a vast landscape of possible theories, perhaps as many as 10,500 different possible configurations, each corresponding to a different set of physical laws. And despite decades of development, it has yet to make a definitive, testable prediction that would distinguish it from other approaches. Loop quantum gravity, which we've also touched on, takes a different route. Rather than trying to unify all forces within a single framework, it focuses specifically on quantizing gravity, on developing a quantum theory of spacetime itself. In this approach, space isn't an empty stage on which particles move, but a dynamic entity composed of discrete units at the Planck scale, about 10^235 meters. These fundamental building blocks form a kind of quantum foam, a network of relationships that gives rise to the smooth space-time we experience at larger scales. Gravity isn't a force propagated by particles, but a manifestation of this network's structure, of how these quantum units of space are connected to each other. Loop quantum gravity offers elegant explanations for certain aspects of black hole thermodynamics and suggests intriguing possibilities for cosmology, including the Big Bounce scenario we've discussed. But, like string theory, it remains a work in progress, with open questions about how ordinary matter and the other fundamental forces fit into its framework. Other approaches to quantum gravity include causal set theory, which models spacetime as a discrete set of events connected by causal relationships, asymptotic safety, which suggests that gravity becomes less rather than more problematic at high energies, and causal dynamical triangulations, which uses computer simulations to show how quantum spacetime might naturally give rise to the four-dimensional universe we observe. Each of these approaches represents a different vision of what space, time, and gravity might be at the most fundamental level. Each offers insights that the others miss, perspectives that illuminate different aspects of the quantum gravity puzzle. And each suggests a different resolution to the singularity problem, a different answer to what might have happened before the Big Bang. What's emerging from this theoretical ferment isn't a single definitive theory, but a constellation of interconnected ideas, a network of approaches that might eventually converge on a deeper understanding. The story of quantum gravity isn't a linear progression toward a final answer, but an exploration of a conceptual landscape, a mapping of possibilities. And this brings us to another profound mystery: the arrow of time. Why does time flow in one direction but not the other? Why do we remember the past but not the future? Why do eggs break but never unbreak? Why does coffee cool but never spontaneously heat up? The fundamental laws of physics, whether classical or quantum, are largely time-symmetric. The basic equations work just as well with time running backward as forward. Yet we experience an obvious asymmetry, a clear distinction between past and future, a one-way flow that defines our existence. This asymmetry is embodied in the second law of thermodynamics. In closed systems, entropy, roughly the measure of disorder or randomness, always increases over time. A broken egg has higher entropy than an intact one. Heat dispersing from coffee into the surrounding air represents an increase in entropy. The second law gives time its arrow, pointing from lower to higher entropy, from order to disorder. But why? What gives time this direction? And was this arrow present at the beginning, or did it emerge later? Some theorists suggest that the arrow of time isn't fundamental but emergent, a consequence of the universe's initial state having extraordinarily low entropy. The universe began in a highly ordered state, though this might seem counterintuitive, given the extreme temperatures and densities, and has been running down ever since, increasing in disorder as it expands and cools. But this just pushes the question back. Why did the universe begin in such an unlikely, low-entropy state? Roger Penrose has calculated that the odds against such a state occurring by chance are so astronomically large that they make winning the lottery every day for 1 billion years seem probable by comparison. Penrose's own solution in his conformal, cyclic cosmology is that the arrow of time resets at the boundary between cycles. As one universe approaches heat death, a state of maximum entropy, where all energy is evenly distributed and no further work is possible, it effectively becomes equivalent to the highly ordered initial state of the next universe. The end of time in one cycle becomes the beginning of time in the next. Other theorists propose that the arrow of time might be connected to quantum phenomena like decoherence, the process by which quantum systems lose their wave-like properties and behave, classically when they interact with their environment. In these models, the distinction between past and future emerges from more fundamental quantum processes, from the way information spreads and becomes entangled across systems. Still, others wonder if the arrow of time might be more fundamental. Then we've recognized not an emergent property, but a basic feature of reality, as essential as space or energy. Perhaps time's flow isn't an illusion or a secondary consequence, but the most real thing there is, the current that carries all existence forward. These perspectives on the arrow of time aren't just abstract physical theories. They reshape our understanding of causality, of how events relate to each other, of what it means for one thing to happen because of another. They suggest that the clear distinction we perceive between cause and effect might not be absolute but contextual, valid within certain frameworks but dissolving at the deepest levels of reality. And this brings us to one of the most radical theoretical frontiers, the block universe. Imagine reality as a film reel again, but this time consider that all frames, past, present, and future, exist simultaneously. In this view, time doesn't flow. Rather, our consciousness moves through an already existing four-dimensional block of spacetime, creating the illusion of past, present, and future. This concept emerges naturally from Einstein's theory of relativity, which treats time as a dimension similar to space. In relativity, there's no absolute universal now. What counts as simultaneous depends on the observer's frame of reference. Different observers moving at different velocities will disagree about which events happen at the same time. This suggests that all moments, what we call past, present, and future, are equally real, existing together in a four-dimensional manifold. The physicist Brian Greene likens this to a loaf of bread. What we experience as now is just one slice of a loaf that exists in its entirety. Our consciousness creates the illusion of time's flow as it moves from slice to slice, but the entire loaf, all of space-time, exists as a complete entity. True, this perspective transforms our understanding of existence itself. Free will becomes problematic. If the future already exists in some sense, how can our choices truly create it? Causality becomes more complex. If all moments exist equally, in what sense does one event cause another? The very notion of becoming, of things coming into existence or passing away, might be a kind of illusion, a product of our limited perspective rather than a fundamental feature of reality. Yet the block universe doesn't necessarily eliminate meaning or purpose. Even if all moments exist already, from a God's-eye view outside of time, from within the system, our choices, our actions, our experiences still matter. The fact that a novel exists in its entirety on a bookshelf doesn't make the story any less meaningful or the characters' choices any less significant within the context of the narrative. Alternatively, some theorists propose a growing block universe where the past and present exist, but the future doesn't. Not yet. In this view, the now represents the leading edge of reality, the boundary where possibility crystallizes into actuality. The block grows moment by moment, with new slices of reality coming into existence as time progresses. Others suggest a presentist view, where only the present moment truly exists. The past is gone. The future hasn't happened yet. This aligns more closely with our intuitive experience, but creates tensions with relativity's treatment of time as a dimension. These competing models of time, the block universe, the growing block, presentism, represent different attempts to reconcile our subjective experience of temporal flow with the mathematical framework of modern physics. Each has its philosophical strengths and challenges, its insights and blind spots, and each suggests a different answer to the question of what exists, of what reality fundamentally is. But the mystery deepens further when we consider another theoretical frontier, the multiverse. What if our universe, vast as it is, represents just one bubble in an infinite cosmic foam, one branch in an ever-splitting quantum tree, one membrane in a higher dimensional bulk? The multiverse isn't a single theory, but a family of related concepts, each emerging from different theoretical frameworks. Let's explore the main variants. The inflationary multiverse arises from cosmic inflation, the theory that the early universe underwent a period of exponential expansion, increasing in size by a factor of at least 10 to 26 in just 10 or 32 seconds. Once inflation begins, it tends to continue indefinitely in most regions, stopping only in isolated patches that become bubble universes like our own. This process, eternal inflation, would generate an infinite number of bubble universes, each with potentially different physical laws and constants. The quantum multiverse emerges from certain interpretations of quantum mechanics, particularly the many-worlds interpretation proposed by Hugh Everett III. In this framework, every quantum event, every moment when a particle's wave function could collapse in different ways, splits reality into multiple branches, each representing a different outcome. All possibilities are realized just in different branches of an ever-proliferating quantum tree. The brain multiverse comes from string theory and its extension, M-theory, which suggests that our three-dimensional universe exists as a brain, membrane in a higher dimensional space. Other brains might exist in the same higher dimensional bulk, potentially interacting with our own through gravity or high-energy phenomena. The mathematical multiverse, proposed by physicist Max Tegmark, suggests that any mathematically consistent structure exists physically. Our universe is just one such structure among an infinite multitude, each corresponding to a different set of mathematical equations, a different possible reality. These aren't just speculative fantasies. They emerge naturally from some of our most successful physical theories. Inflation resolves key problems in cosmology. Quantum mechanics has been confirmed to astonishing precision. String theory offers promising approaches to quantum gravity. Mathematics has proven extraordinarily effective at describing physical reality. If any of these multiverse concepts is correct, the implications are profound. Our universe, already so vast that it strains comprehension, would be an infinitesimal fraction of reality. The diversity of physical conditions, of possibilities, of forms that existence can take would be far greater than we've imagined. And our place in this larger reality would be both humbling and thought-provoking. The multiverse offers a natural explanation for one of the most puzzling features of our universe, its apparent fine-tuning for complexity, for the emergence of stars, planets, life. The physical constants, the strength of gravity, the mass of the electron, the energy of the vacuum, seem calibrated with impossible precision. Change any one of them slightly, and stars couldn't form, atoms couldn't assemble, chemistry couldn't function, complexity couldn't emerge. This observation has been used to argue for design, for a creator who intentionally set these parameters to allow for life. But in a vast or infinite multiverse, with varying laws and constants, regions hospitable to life will inevitably exist somewhere. And it's no surprise that we find ourselves in such a region. Life can only arise in universes compatible with its existence, so we necessarily observe a universe that appears fine-tuned for life. This is known as the anthropic principle, not an explanation so much as a selection effect. But the multiverse raises its own profound questions. If it exists, is it testable? Can we detect the influence of other universes on our own? Are there signatures of cosmic collisions imprinted on our cosmic microwave background? Can we find evidence of quantum branching or of higher dimensions? Some theorists have proposed potential tests, from subtle patterns in the cosmic microwave background that might indicate interactions with other bubble universes, to the detection of gravitational waves that could reveal extra dimensions, to anomalies in quantum experiments that might suggest influences from parallel branches. But these tests remain speculative, at the frontier of what's currently possible. Others worry that the multiverse concept risks becoming unfalsifiable, slipping from science into metaphysics. If we can't observe other universes even in principle, if they forever remain beyond our cosmic horizon, can the multiverse be considered a scientific theory at all? Or is it more properly viewed as a philosophical framework, a way of interpreting our theories rather than a testable proposition in its own right? These questions blur the boundary between physics and philosophy, between empirical science and conceptual analysis. They remind us that our theories don't just describe reality. They also shape how we conceptualize it, how we frame our questions, how we define what counts as an explanation. And they lead us to perhaps the most fundamental question of all: what is reality itself? Is it fundamentally mathematical, as Tegmark's mathematical universe hypothesis suggests? Is it informational, composed of bits rather than particles, as proposed by digital physics? Is it computational, a vast simulation or calculation unfolding according to algorithmic rules? Or is it something else entirely, something our current conceptual frameworks can't fully capture? These aren't just abstract speculations, they're attempts to get at the deepest level of reality, to penetrate the veil of appearances and glimpse the machinery behind. They emerge naturally from our best theories, from the mathematical descriptions that have proven so successful in explaining what we observe, and they return us to the central question: what lies at the core? Not just the physical core, the origin point of the Big Bang, the heart of a black hole, but the conceptual core, the essence of existence itself. What fundamental principle, what underlying reality supports the cosmos as we experience it? But before we dive deeper into these philosophical waters, let's explore another frontier where our understanding breaks down. Black holes. These cosmic objects where gravity becomes so intense that nothing, not even light, can escape, aren't just extreme astrophysical phenomena. They're laboratories for quantum gravity, windows into the fundamental nature of space, time, and information. According to general relativity, at the center of a black hole lies a singularity, a point of infinite density where space-time curves infinitely. But, as with the Big Bang singularity, this is likely a sign that our theories are incomplete. Quantum effects must become important near the singularity. modifying the classical picture in ways we don't yet fully understand. Black holes raise profound questions about information and its conservation. Quantum mechanics suggests that information can never be truly destroyed. The complete state of a system at one time determines its state at all future times, at least in principle. Yet black holes seem to erase information completely. Whatever falls in, whether a star, a planet, or a quantum-encoded message, is reduced to just three parameters: mass, charge, and angular momentum. All other details are apparently lost. This information paradox has led to heated debates among physicists, with proposed resolutions ranging from subtle quantum effects at the event horizon, the boundary beyond which nothing can escape, to exotic structures like firewalls or fuzzballs that replace the classical black hole interior. The breakthrough came with Stephen Hawking's discovery of black hole radiation. Quantum effects near the event horizon cause black holes to emit particles, gradually losing mass in the process. Eventually, a black hole will evaporate completely. But this raises a new puzzle. What happens to the information that fell in? Is it somehow encoded in the radiation? Is it irretrievably lost, contradicting quantum principles? Or does it escape through some other mechanism? One proposal, from Juan Maldacena and Leonard Susskind, suggests that quantum entanglement, the spooky connection between particles that Einstein called spooky action at a distance, might provide the answer. They propose that particles inside and outside a black hole remain connected by Einstein-Rosen bridges, essentially wormholes linking different regions of spacetime. Information isn't lost, it's transferred through these quantum connections. This idea, summarized in the slogan San for EPR, Einstein-Rosen bridges equal Einstein-Podolsky-Rosen entanglement, suggests a deep connection between quantum entanglement and spacetime geometry. Entanglement, a quantum phenomenon, might be the thread from which the fabric of space itself is woven. And this brings us to one of the most revolutionary ideas in theoretical physics: emergent spacetime. What if space itself isn't fundamental, but emerges from more basic quantum relationships? What if the smooth, continuous three-dimensional arena we experience is a kind of collective behavior, a macroscopic property arising from microscopic quantum entanglement? This perspective is embodied in the holographic principle, inspired by black hole thermodynamics and fully realized in the ADS-CFT correspondence developed by Maldacena. It suggests that the information contained in a volume of space can be entirely encoded on its boundary, just as a two-dimensional hologram can create the illusion of three dimensions. In the ADS-CFT framework, a quantum theory without gravity in a certain number of dimensions is mathematically equivalent to a gravitational theory in one higher dimension. This isn't just an analogy or a computational trick. It suggests that the gravitational dimension, space itself, might be emergent, a manifestation of quantum entanglement in the boundary theory. If true, this would transform our understanding of space, time, and gravity. Space wouldn't be a thing, a substance, a fundamental entity, but a consequence of quantum relationships, a pattern of entanglement. Gravity wouldn't be a force in the conventional sense, but an emergent phenomenon, a manifestation of the way quantum information is organized. These ideas remain at the frontier of theoretical physics, not yet fully developed or confirmed. But they suggest a profound reconceptualization of reality, a shift from thinking of space as the container in which things happen to seeing it as an emergent property of how things are connected, how information is structured. And they point toward a deeper unity underlying the seemingly disparate mysteries we've been exploring: the singularity, quantum gravity, the arrow of time, the multiverse, black holes. These might not be separate puzzles, but different aspects of a single, deeper question. What is the fundamental nature of reality, and how does the world we experience emerge from it? This brings us to another theoretical frontier, one that bridges physics and philosophy, quantum mechanics and consciousness. The measurement problem in quantum mechanics, the way that observation seems to collapse probability waves into definite states, has led some to suggest that consciousness might play a fundamental role in reality. In the standard Copenhagen interpretation of quantum mechanics, a particle exists in a superposition of multiple possible states until it's measured, at which point the wave function collapses into a single definite state. But what constitutes a measurement? Does it require a conscious observer, or is any physical interaction sufficient? And what happens during the collapse? Is it a physical process, or something else entirely? These questions have spawned a variety of interpretations, from the many worlds interpretation, where all possibilities are realized in branching universes, to the pilot wave theory, where particles have definite positions guided by a wave function, to quantum Bayesianism, where the wave function represents the observer's knowledge rather than an objective reality. Some theorists, including Roger Penrose and Stuart Hameroff, have proposed that consciousness itself might be a quantum phenomenon, involving superpositions at the level of neural microtubules that collapse through a process called objective reduction. Others, like physicist Henry Stapp, suggest that quantum mechanics provides a natural framework for understanding how mind might interact with matter. These ideas remain speculative, controversial, at the boundaries of what current science can address, but they arise naturally from the strange properties of quantum mechanics, from the apparent role of observation in determining what exists, from the mysterious connection between information, probability, and physical reality, and they suggest a profound possibility that consciousness might not be an accidental byproduct of physical processes, but an integral aspect of reality, as fundamental in its way as space, time, or energy. Not in a mystical or supernatural sense, but in the sense that the capacity for experience, for subjectivity, might be woven into the fabric of the cosmos. This perspective, sometimes called panpsychism, proposes that consciousness isn't something that emerges at a certain level of physical complexity, but a fundamental feature of reality that exists in some form at all levels, becoming more complex and integrated in systems like brains. It suggests that the hard problem of consciousness, why physical processes should give rise to subjective experience at all, might be resolved by recognizing that experience isn't something that emerges from non-experiential components, but a basic aspect of what exists. Whether or not this view is correct, and it remains highly controversial among both scientists and philosophers, it represents an attempt to integrate consciousness into our understanding of the physical world, to see it not as something separate from or opposed to physical reality, but as an aspect of that reality itself. And it returns us to a theme we've touched on throughout: the possibility that reality isn't just what we observe, but how we observe it, that the universe isn't just stuff, but also perspective, not just being, but also knowing. Not in a solipsistic way that denies objective reality, but in a way that recognizes the inseparability of observer and observed at the deepest levels. This doesn't mean abandoning objectivity or empirical science. Quite the opposite. It means recognizing that objectivity itself is a perspective, a way of knowing that has proven extraordinarily powerful, but is not the only way, not the complete story. The view from nowhere is still a view from somewhere. The universe doesn't just exist. It exists for us, through us, as us. We are the means by which the cosmos contemplates itself, questions itself, wonders at itself. We are stardust become conscious, the universe looking back at itself in awe. And perhaps that, in the end, is what lies at the core. Not just physical processes, not just mathematical structures, but the potential for awareness, for wonder, for meaning. Perhaps consciousness itself, in all its forms throughout the cosmos, is not peripheral, but central to the cosmic story. If so, then our quest to understand the core is itself part of what the core is. The universe's own self-inquiry, existence questioning its own nature. The seeker and the sought are not separate, but aspects of a single process. A cosmic feedback loop of being and knowing. This perspective transforms the scientific project from a purely objective investigation of external reality to a participatory exploration in which we are both investigators and, in a sense, the investigated. Not in a solipsistic way that denies objective reality, but in a way that recognizes the inseparability of observer and observed at the deepest levels. But let's step back from these philosophical depths and return to the empirical foundation. What does the evidence actually tell us about the universe's birth, about the conditions at the beginning, about what might have preceded the Big Bang, if anything? The cosmic microwave background radiation gives us a snapshot of the universe at 380,000 years after the beginning, the earliest direct observation we can make. Before that, the universe was opaque to electromagnetic radiation. To probe earlier times, we need other messengers. Gravitational waves, ripples in space-time itself, offer one possibility. Unlike light, they can travel through the opaque early universe, potentially carrying information from the first fraction of a second after the Big Bang. Advanced detectors like LIGO and Virgo have already observed gravitational waves from colliding black holes and neutron stars. Future space-based detectors might be sensitive enough to detect the faint echoes of creation itself. Neutrinos, nearly massless particles that rarely interact with ordinary matter, might also carry information from the early universe. The cosmic neutrino background, analogous to the cosmic microwave background but much harder to detect, would give us a picture of the universe just 1 second after the Big Bang. But let's now dive into another frontier where our understanding is being revolutionized: dark matter and dark energy. These invisible components, which together make up about 95% of the universe's energy content, represent one of the most profound mysteries in modern cosmology. Dark matter, which accounts for about 27% of the universe, doesn't emit, absorb, or reflect light. It's completely invisible to electromagnetic radiation. We detect it only through its gravitational effects. The rotation curves of galaxies, the dynamics of galaxy clusters, the patterns of gravitational lensing, where massive objects bend light from distant sources. The evidence for dark matter's existence is overwhelming, yet despite decades of searching, no dark matter particle has ever been directly detected. Our most sensitive experiments, deep underground detectors shielded from cosmic rays, powerful particle accelerators smashing protons together at nearly the speed of light, have found nothing. The candidates keep shifting, from massive neutrinos to axions, from weakly interacting massive particles, WIMPs, to strongly interacting massive particles, SIMPs, from primordial black holes to sterile neutrinos. Each has its theoretical appeal, its particular way of fitting into our understanding of particle physics and cosmology, yet each has eluded definitive detection. Some theorists propose more exotic possibilities. Dark matter might not be particles at all, but topological defects in spacetime, like cosmic strings or domain walls. It might be a manifestation of extra dimensions, gravity leaking from a higher dimensional brain into our three-dimensional world. It might be a form of matter from a hidden sector of particle physics, interacting with ordinary matter only through gravity and perhaps a new yet undiscovered force. Or dark matter might not exist at all, Modified Newtonian dynamics, AMOND, and its relativistic extensions suggest that gravity might behave differently at galactic scales than our current theories predict. These alternatives have their own problems. They struggle to explain the full range of observations that dark matter accounts for. But they remind us that even the most established pillars of our cosmological model might be reinterpreted. Dark energy, which makes up about 68% of the universe, is even more mysterious. Discovered in 1998 through observations of distant supernovae, it's responsible for the accelerating expansion of the universe, pushing galaxies apart faster and faster as cosmic time progresses. The simplest explanation is that dark energy is the energy of empty space itself, what physicists call vacuum energy, or the cosmological constant. But when we try to calculate how much energy empty space should contain, according to quantum field theory, we get a value that's wrong by 120 orders of magnitude. Perhaps the most dramatic disagreement between theory and observation in the history of science. This cosmological constant problem has been called the worst theoretical prediction in physics. It suggests that we're missing something fundamental about how quantum fields interact with gravity, about the nature of empty space, about the relationship between energy and space-time. Alternative explanations for dark energy include dynamical, scalar fields, similar to the inflaton field that drove cosmic inflation, modifications to Einstein's theory of gravity at cosmic scales, or even the possibility that the accelerating expansion is an illusion, a misinterpretation of our position in a vast cosmic structure, a kind of gigantic bubble in the cosmic foam. These mysteries, dark matter and dark energy, aren't peripheral puzzles, but central challenges to our understanding of the cosmos. They remind us that what we can directly observe, stars, galaxies, gas clouds, all the forms of matter that emit or interact with electromagnetic radiation, represents just a small fraction of what exists. The universe is far stranger, far more diverse in its constituents than our everyday experience suggests. And they point to a profound humility. After centuries of scientific progress, of increasingly precise observations and increasingly powerful theories, we still don't know what 95% of the universe is made of. Our ignorance vastly exceeds our knowledge. But this ignorance isn't cause for despair. It's an invitation to discovery, a frontier waiting to be explored. Each mystery, each anomaly, each discrepancy between theory and observation is a clue, a signpost pointing toward deeper understanding. And now, let's turn to one of the most profound theoretical developments in recent decades, the holographic principle. We've touched on this earlier, but it deserves closer. We've been exploring the universe as scientists, as investigators, as analytical minds trying to solve the greatest puzzle in existence. But now, let's look at what this all means. Not just as observers, but as participants in this cosmic drama. Because that's what you are. Not a passive spectator, but a conscious node in the vast network of reality. A collection of atoms that has somehow awakened to contemplate its own existence. Take a moment. Feel the weight of your body, the rhythm of your breath, the thoughts forming in your mind as you process these words. All of this, your entire lived experience, exists within the framework we've been dissecting. You are not separate from these cosmic mysteries. You are made of them. If the universe truly began in a singularity, then every atom in your body was once compressed into that infinitesimal point. The carbon in your cells, the iron in your blood, the calcium in your bones, all of it existed in that unimaginably dense, hot state at the dawn of time. You are not just living in the universe, You are the universe experiencing itself. When you contemplate the cosmos is contemplating itself through you. But what does it mean that your constituent parts, the very stuff of your physical being, once existed in a state where space and time themselves break down? Where our equations fail, where our conceptual frameworks collapse, you emerged from something that defies understanding. At the most fundamental level, you are rooted in mystery. And if the multiverse theory is correct, what then? Somewhere, in some other bubble of space-time, in some parallel branch of the quantum wave function, there are versions of you making different choices, living different lives. Perhaps in one, you became an astronaut instead of watching this video. Perhaps in another, you were never born at all. Perhaps in countless others, the physical constants are such that matter as we know it never formed, and consciousness never emerged. If every quantum possibility branches reality, then your entire life is just one path through an infinite forest of what could have beens. The you experiencing these words right now is just one facet of a vast, multidimensional entity sprawling across realities. Does that diminish your significance or magnify it beyond comprehension? Consider the block universe theory we discussed. That's the idea that all moments in time exist simultaneously, that the distinction between past, present, and future is an illusion of consciousness. If true, this means that your birth, your death, and every moment in between exist permanently in the four-dimensional structure of space-time. Nothing is ever truly lost. The most precious moments of your life aren't gone. They're just in a different location in the timescape, as real and as present as the moment you're experiencing now. But it also means that the sense of becoming, of potential, of an open future being created by your choices might be an illusion, a trick of how consciousness experiences the temporal dimension. If time is an illusion, then everything you've ever done and everything you will ever do might have already happened. Infinite times before, across the vast expanse of the multiverse. Are, decode, your choices still meaningful? Is free will compatible with a block universe, with a predetermined timescape? These aren't just abstract philosophical questions. They cut to the core of how we understand our own existence, our own agency, our own purpose, and what of consciousness itself. That mysterious first-person experience that allows you to witness the universe, to feel emotions, to contemplate these ideas. We've seen how some theories suggest consciousness might be fundamental rather than emergent, woven into the fabric of reality rather than arising solely from complex neural activity. What if the capacity for experience, for subjectivity, for awareness, isn't unique to brains, but exists in some form at all levels of reality? What if electrons have some primitive form of experience, some rudimentary awareness? What if stars do, or galaxies, or the universe itself? What if the cosmos isn't just blindly following mathematical laws, but experiencing its own unfolding in ways we can barely imagine? This isn't mere mysticism. It's a serious philosophical position known as panpsychism, with advocates among respected physicists and philosophers. It suggests that consciousness isn't something that emerged at some arbitrary point in cosmic evolution, but has been there all along, becoming more complex, more integrated as matter organized itself into more complex forms. If true, this would transform your relationship to reality. You wouldn't be an isolated consciousness in an unconscious universe, but a particular expression of a universe that is conscious all the way down. Your awareness would be continuous with the awareness in all things, differing in degree and complexity, but not in kind. But let's step back from these philosophical speculations to something more concrete yet equally profound: the arrow of time. We've seen how time's one-way flow, from past to future, from order to disorder, might be connected to the universe's initial state of extraordinarily low entropy. The universe began in a highly ordered state and has been running down ever since, increasing in disorder as it expands and cools. This process, this cosmic unwinding, is what gives time its direction. It's what allows eggs to break but never unbreak, coffee to cool but never spontaneously heat up, people to age but never grow younger. It's the process that will eventually lead to the heat death of the universe, when all energy is evenly distributed and no further work is possible. But this same process, this increase in entropy, is also what allows for the local decreases in entropy that constitute life, consciousness, civilization. Living systems maintain their order by exporting entropy to their surroundings. Your body, your brain, your thoughts, all of these are temporary islands of increasing order in a sea of increasing disorder. You are, in a very real sense, swimming against the cosmic current. Your existence, your life, your consciousness is a local rebellion against the universe's fundamental tendency toward disorder. Every moment you exist, every thought you think, is a triumph against cosmic inevitability. But it's a temporary triumph. Eventually, the arrow of time catches up with all of us. Our bodies age and die. Our civilizations rise and fall. Our planet will one day be consumed by its expanding sun. Our galaxy will collide with Andromeda. And in the far, far future, trillions upon trillions of years from now, the universe itself will approach heat death, a state of maximum entropy where no further work is possible, where time itself becomes meaningless because nothing changes. Unless, of course, one of the cyclic models we discussed is correct. Perhaps the end of one universe becomes the beginning of the next. Perhaps when one cosmic film reel ends, another begins to play. Perhaps time's arrow isn't absolute but periodically reverses, with expansion giving way to contraction, entropy increase giving way to entropy decrease. If so, then the story has no end. Just endless cycles of creation and destruction, of expansion and contraction, of order and disorder. Your atoms, the very substance of your being, would be recycled through infinite cosmic iterations, taking part in an eternal dance of becoming and dissolving. But now, let's confront something more immediate, more visceral, the scale of it all. The observable universe is approximately 93 billion light-years in diameter, a sphere containing perhaps 2 trillion galaxies, each with hundreds of billions of stars. Our Sun is one such star, an unremarkable yellow dwarf in an unremarkable spiral arm of an unremarkable galaxy. Earth orbits this unremarkable star at a distance of about 93 million miles, a cosmic hair's breadth, and on the surface of this tiny planet, in an infinitesimal fraction of cosmic time, conscious beings evolved who dared to contemplate the whole. The scales involved defy intuition. If the Sun were the size of a grapefruit, Earth would be a pinhead, about 15 feet away, and the nearest star would be 2,500 miles distant. On this scale, the Milky Way galaxy would span North America, and the observable universe would be larger than the actual Earth. Or consider time. If the history of the universe were compressed into a single Earth year, with the Big Bang on January 1 and the present moment at midnight on December 31st, then the first stars would form around January 13th. Our Sun and solar system would appear in late August. Life on Earth would begin in September. Dinosaurs would roam from December 25 to December 30. The entire history of human civilization would unfold in the final minutes of December 31st. Your lifetime would occupy a fraction of the last second. This is cosmic horror. not in the sense of monsters or existential dread, but in the sense of scales so vast, so incomprehensible that they shatter our anthropocentric frameworks. We are vanishingly small, vanishingly brief against the cosmic backdrop. Our individual lives are less than a blink in cosmic time. Our planet less than a speck in cosmic space. And yet, here we are, conscious, aware, capable of contemplating the whole. In all this immensity, in all this cosmic history, we are among the beings who can ask why, who can seek meaning, who can wonder at it all. Our consciousness, that mysterious first-person experience that allows you to witness reality, might be the rarest, most precious phenomenon in the cosmos. Because, as far as we know, most of the universe is unconscious. Stars burn without awareness. Galaxies spin without purpose. Black holes devour without intention. Only on this tiny planet, only in the thin film of biosphere clinging to its surface, only in the flicker of cosmic time we call history, has matter organized itself into forms capable of wondering why it exists. This doesn't mean we're the center of cosmic importance. That would be a return to the anthropocentrism that science has repeatedly dethroned. But it does suggest that consciousness, wherever and however it arises, is a rare and remarkable phenomenon, a way for the cosmos to witness itself, to reflect on its own existence. In this sense, you, yes, you, experiencing these words right, now are the universe's way of knowing itself. You are cosmos become conscious, stardust that has awakened. Your experiences, your thoughts, your emotions are the universe experiencing, thinking, feeling through one of its countless manifestations. This isn't mysticism, it's empirical fact. You are made of the same elements formed in stellar furnaces, organized according to the same physical laws that govern galaxies and black holes, subject to the same cosmic history that shapes everything in existence. You're not separate from the universe. You're an expression of it, a particular configuration of the same fundamental reality. But what if this fundamental reality isn't what we think it is? What if the solid, three-dimensional world around us, the stars in the sky, the ground beneath our feet, our own bodies moving through space, is an elaborate holographic projection, as the holographic principle suggests? What if space itself is emergent, arising from quantum entanglement on some distant boundary? If true, this would mean that your sense of inhabiting three-dimensional space is an illusion, albeit an extremely convincing one. Your perception of depth, of solidity, of spatial extension would be a way for your consciousness to organize and make sense of information that's actually encoded on a lower dimensional surface. It would be as if you were a character in a sophisticated, virtual reality simulation, convinced of the reality of your three-dimensional world, while the actual computation happens on a two-dimensional processor. The processor, in this case, would be the boundary of our universe, and the computation would be the unfolding of physical law. But unlike a conventional simulation, there would be no outside programmer, no external reality running the show. The boundary and the bulk, the code and the experience would be two aspects of the same underlying reality, two languages describing the same truth. What would this mean for your sense of self, for your understanding of your place in the cosmos? If space itself is emergent, what else might be? Time? Causality? Identity? What aspects of your experience that seem fundamental might actually be elaborate constructions, ways for consciousness to navigate a reality far stranger than our everyday? Perception suggests these questions blur the boundary between physics and philosophy, between empirical science and existential reflection. They remind us that our theories don't just describe reality, they also shape how we conceptualize it, how we frame our questions, how we define what counts as an explanation. And they lead us to perhaps the most fundamental question of all. What is reality itself? Is it fundamentally mathematical, as some theories suggest? Is it informational, composed of bits rather than particles? Is it computational, a vast calculation unfolding according to algorithmic rules? Or is it something else entirely? Something our current conceptual frameworks can't fully capture? These aren't just abstract speculations. They're attempts to get at the deepest level of reality, to penetrate the veil of appearances and glimpse the machinery behind. They emerge naturally from our best theories, from the mathematical descriptions that have proven so successful in explaining what we observe. And they return us to the central question: what lies at the core? Not just the physical core, the origin point of the Big Bang, the heart of a black hole, but the conceptual core, the essence of existence itself. What fundamental principle, what underlying reality supports the cosmos as we experience it? Perhaps the most vertigo-inducing possibility is that there is no bottom level, no fundamental reality beneath appearances. Perhaps it's turtles all the way down, with each level of explanation giving way to another, each rock bottom revealing new depths beneath. Perhaps there is no final theory, no ultimate level of description, just an endless series of models, each more comprehensive than the last, but none exhaustive. Or perhaps there is a limit to this descent, a fundamental level beyond which reality cannot be further decomposed. But this core might not be what we expect. Not a particle, not a field, not even a mathematical structure, but something more fundamental still. What if the universe is alive, and we are just its fleeting thoughts? This isn't mere poetic license. Some serious thinkers have proposed that the cosmos as a whole might possess properties we'd associate with life or even consciousness, not in the anthropomorphic sense of a cosmic person with human-like thoughts and emotions, but in the sense of an integrated system with complex, self-organizing behavior that maintains itself far from equilibrium. Cosmologist Lee Smolin has suggested that universes might evolve through a kind of cosmic natural selection, with black holes giving birth to new universes with slightly varied properties. Universes that produce many black holes would have more offspring, leading to an evolutionary process that might favor universes capable of generating complexity, stars, perhaps even life. Others, inspired by the Gaia hypothesis of Earth as a self-regulating system, have proposed that the universe itself might be homeostatic, maintaining conditions conducive to its own persistence through complex feedback mechanisms. Still others have wondered if consciousness, rather than being a late-emerging phenomenon in cosmic history, might be fundamental to reality itself. These speculations remain at the fringe of scientific discourse, neither proven nor disproven, neither embraced nor entirely dismissed. But they remind us that our categories, living versus non-living, conscious versus unconscious, active versus passive, might be too rigid, too anthropocentric to capture the full strangeness of cosmic reality. And they raise a profound possibility that your relationship to the cosmos isn't just that of a part to a whole, of a tiny subsystem to a vast system, but of a thought to a mind, of a dream to a dreamer. Not in a mystical or supernatural sense, but in the sense that consciousness at the human scale might be continuous with processes at the cosmic scale, differing in degree and complexity, but not in kind. If true, this would transform your understanding of existence itself. You wouldn't be an accidental byproduct of blind physical processes, but an expression of the universe's intrinsic tendency toward complexity, awareness, self-reflection. Your consciousness wouldn't be an anomaly in an unconscious cosmos, but a particular manifestation of a cosmos that is in some sense aware all the way up and all the way down. But even if we set aside these more speculative ideas, the established science we've explored raises equally profound existential questions. Consider the multiverse again. If infinite versions of you exist across parallel realities, what does that mean for your sense of uniqueness, of individual identity? Are you a single continuous entity, or are you more like a vast multidimensional pattern, a resonance across realities? Is your sense of being a specific individual with a particular history and a unique future an illusion, a limited perspective that fails to capture your full multiversal nature? And what of free will in such a framework? If every possible choice branches reality, creating new universes where alternative decisions are made, are you truly choosing anything? Or are you simply experiencing one branch of an ever-splitting tree, with other versions of you experiencing different branches? These questions aren't just philosophical puzzles. They touch the core of how we understand ourselves, our agency, our purpose. They force us to confront the possibility that our most basic assumptions about reality, that things either are or aren't, that causes precede effects, that the past is fixed while the future is open, might be provisional, valid within certain contexts, but breaking down at the deepest levels. What if everything you've ever lost still exists, preserved in the timeless structure of the block universe? What if everyone who has ever lived is still alive, just in a different location in the timescape? What if death itself isn't an ending but a boundary, a horizon beyond which experience continues in forms we can't currently imagine? Again, these aren't mystical speculations but implications of serious scientific theories. The block universe emerges naturally from Einstein's theory of relativity, which treats time as a dimension similar to space. In this framework, death isn't the cessation of existence, but a particular temporal boundary. Like the edge of a book, the entirety of your life, from birth to death, exists as a complete four-dimensional object in space-time. Or consider quantum immortality, a thought experiment arising from the many worlds interpretation of quantum mechanics. It suggests that, from a first-person perspective, you might never experience death. In any situation where death is a possibility, your consciousness would continue along the branch where you survive, however improbable that branch might be from an external perspective. These ideas don't negate the reality of loss or the finality of death as we experience them, but they do suggest that our intuitive understanding of time, of identity, of mortality might be incomplete, limited by our particular perspective as macroscopic beings evolving in a specific environment. And they return us to a central theme. The universe is not only stranger than we imagine, it's stranger than we can imagine. Our cognitive apparatus evolved to track savanna predators and social alliances, not to intuit quantum fields or 11-dimensional manifolds. The fact that we can approach these concepts at all, even indirectly through mathematics, is remarkable. There's something profound in this predicament. Creatures of the middle scale, neither cosmic nor quantum, striving to comprehend both. We exist at the interface between the immensely large and the infinitesimally small, between the age of the universe and the lifetime of subatomic particles. Perhaps this position isn't accidental but necessary. Perhaps consciousness itself requires this middle ground, this balance point between extremes. If so, then our perspective, limited as it is, might still offer something unique, something valuable to the cosmic story. Not a God's eye view of totality, but a situated, embodied understanding that embraces its own partiality while continuing to reach beyond it. This is the great paradox of human existence. We are simultaneously cosmic, specks and cosmic comprehenders, vanishingly small in space and time yet capable of grasping the whole. at least partially. We are the universe becoming aware of itself, matter reflecting on its own nature, space-time curved back upon itself in the form of conscious thought. And perhaps that's what lies at the core of it all. Not a thing, not a substance, not even a process, but a kind of cosmic self-relation, a fundamental reflectivity that manifests across scales, from quantum entanglement to conscious awareness. Perhaps the universe isn't just a collection of objects and events, but a self-organizing, self-complexifying, self-reflecting system. A reality perpetually coming to terms with itself. If so, then your existence isn't an accident or a side effect, but an expression of the cosmos's intrinsic tendency toward self-relation, toward complexity, toward awareness. Your consciousness isn't separate from the cosmic process, but continuous with it. A particular manifestation of the universe's fundamental nature. But now, let's confront an even more unsettling possibility. What if the universe isn't just stranger than we imagine, but more indifferent, more alien to human concerns than we're comfortable admitting? Cosmic evolution unfolds according to physical laws that seem entirely indifferent to life, to consciousness, to meaning as humans understand it. Stars explode, galaxies collide, black holes devour everything in their path. Not with malice or purpose, but simply as the inevitable consequence of how gravity, nuclear forces, and thermodynamics operate at cosmic scales. The universe exists and evolves regardless of whether anyone is watching, regardless of whether its processes are understood or appreciated. It was here long before humans evolved and will continue long after our species is extinct. From this perspective, all human concerns, our loves and fears, our aspirations and achievements, our search for meaning and purpose, seem parochial, limited, perhaps even delusional. This cosmic indifference can induce a kind of existential vertigo, a disturbing sense that all human values, all human meanings are merely local, temporary, arbitrary patterns in a vast, impersonal cosmos. The universe doesn't care whether you live or die, whether humanity flourishes or perishes, whether consciousness expands throughout the cosmos or flickers out on this single, unremarkable planet. The 20th century philosopher Albert Camus captured this sentiment in his essay The Myth of Sisyphus, where he described the absurd, the confrontation between human desires for meaning, purpose, coherence, and an indifferent universe that offers none of these things. For Camus, the fundamental philosophical question was whether life is worth living in the face of this cosmic silence. But there's another way to view this situation, one that finds profound significance precisely in the contrast between cosmic indifference and human meaning-making. Yes, the universe as a physical system doesn't care about us, but we care. We create meaning, purpose, value through our choices, our relationships, our creative acts, our efforts to understand. In a cosmos governed by blind physical processes, the emergence of beings who can ask why, who can create art, who can love, who can contemplate their own mortality, this is remarkable, perhaps even miraculous, though not in a supernatural sense. The fact that meaning exists at all in an apparently meaningless universe might be the greatest mystery of all. And perhaps this capacity for meaning-making, for finding or creating purpose in an indifferent cosmos, is itself an expression of something fundamental about reality. Perhaps consciousness, with its intrinsic orientation toward meaning, isn't an aberration or an accident, but a manifestation of the universe's tendency toward increasing complexity, toward self-organization, toward self-relation. After all, the same physical laws that govern stellar evolution also govern the formation of complex molecules, the emergence of life, the development of brains capable of contemplating their own existence. The same cosmos that seems indifferent to human concerns also produced humans with their concerns, their values, their search for meaning. This suggests a profound continuity between cosmic processes and human meaning-making, between the physical universe and the realm of consciousness and value. Not an identity. Human purposes aren't the same as physical laws, but a continuity, a relationship, perhaps even a kind of emergence, where meaning arises from but isn't reducible to physical processes. In this view, the universe isn't inherently meaningful or meaningless. It's the ground from which meaning emerges through conscious engagement. Like quantum phenomena that manifest definite properties only when measured, perhaps cosmic meaning exists as potential, as possibility, crystallizing into actuality through conscious interaction, through the questions we ask, the values we hold, the purposes we pursue. This doesn't solve the existential dilemma, but it reframes it. Instead of seeing human meaning as a fragile illusion in an indifferent cosmos, we might see it as an emergent reality, as valid and significant in its domain as physical laws are in theirs. Not a delusion to be overcome, but a creative engagement to be embraced. A way of participating in cosmic evolution rather than merely witnessing it. And this brings us back to where we began. You, experiencing these words right now, a conscious node in the vast network of reality, a collection of atoms that has somehow awakened to contemplate its own existence. You are not separate from these cosmic mysteries. You are made of them, shaped by them, an expression of them. Your consciousness, that mysterious first-person experience that allows you to witness the universe, to feel emotions, to contemplate. These ideas isn't just a byproduct of neural activity, but a manifestation of the universe's intrinsic potential for awareness, for self-relation, for meaning-making. Your thoughts aren't just electrochemical signals in your brain. They're the cosmos thinking through you, the universe exploring its own nature through one of its countless conscious expressions. This doesn't mean you're the center of cosmic importance. That would be a return to an anthropocentrism that science has repeatedly dethroned. But it does suggest that consciousness, wherever and however it arises, is a significant cosmic phenomenon. A way for the universe to witness itself, to reflect on its own existence, to create meaning from within rather than receiving it from without. In this sense, your life, with all its joys and sorrows, its moments of clarity and confusion, its searches for purpose and meaning, isn't peripheral to the cosmic story, but integral to it. Not because human concerns matter on cosmic scales, but because the capacity for concern itself, for caring about anything at all, represents something remarkable in a universe that, as physicist Erwin Schrödinger put it, is not only unknown, it is, in a certain sense, unknowable, except where it interacts with a knowing subject, with you or me. This interaction, this dialogue between consciousness and cosmos, between the knowing subject and the known object, might be what lies at the core of existence. Not a thing, not a substance, not even a process, but a fundamental relationship, a perpetual engagement between awareness and its objects, between the witness and the witnessed, between being and knowing. If so, then your existence isn't an accident or a side effect, but an expression of the cosmos's intrinsic tendency toward self-relation, toward complexity, toward awareness. Your consciousness isn't separate from the cosmic process, but continuous. With it, a particular manifestation of the universe's fundamental nature. But let's push further into the existential implications of the science we've explored. What if time itself, the medium in which you experience your life unfolding, the framework that structures your memories, your anticipations, your sense of becoming, is radically different from what you intuitively believe? The block universe theory suggests that all moments, past, present, and future, exist simultaneously in a four-dimensional manifold of spacetime. Your experience of the present moment as privileged, as more real than past or future, would be an illusion, a product of how consciousness moves through this timescape, creating the appearance of flow where there is only structure. If true, this would mean that your entire life, from birth to death, with all its events, choices, experiences, exists as a complete four-dimensional object in space-time. Nothing is ever truly lost. Nothing ever truly comes into being. The now isn't ontologically special, but merely the section of your world line that you're currently experiencing. This doesn't necessarily negate free will or moral responsibility, but it does reframe them. Your choices would still be yours, still shaped by your values, your character, your reasoning, but they would exist timelessly in the block universe rather than coming into being moment by moment. The future wouldn't be open in an absolute sense, but only relative to your limited temporal perspective. Or consider the many worlds interpretation of quantum mechanics, which suggests that reality constantly branches, with every quantum event creating new universes where different outcomes occur. If true, this would mean that your life isn't a single path, but a vast, branching tree of possibilities, with countless versions of you experiencing different choices, different circumstances, different fates. What would this mean for your sense of identity, for your understanding of choice and consequence? If every possible decision is actualized in some branch of reality, are you truly choosing anything? Or are you simply experiencing one branch of an ever-splitting tree, with other versions of you experiencing different branches? These questions blur the boundary between physics and philosophy, between empirical science and existential reflection. They remind us that our theories don't just describe reality, they also shape how we conceptualize it, how we frame our questions, how we define what counts as an explanation, and they lead us to perhaps the most fundamental question of all. What is reality itself? Is it fundamentally mathematical, as some theories suggest? Is it informational, composed of bits rather than particles? Is it computational, a vast calculation unfolding according to algorithmic rules? Or is it something else entirely, something our current conceptual frameworks can't fully capture? But perhaps the most profound implication of all concerns death itself, that universal human experience that frames our existence, that gives urgency to our projects, poignancy to our relationships, significance to our choices. What might modern physics tell us about the nature of mortality? The block universe suggests that death isn't the cessation of existence, but a temporal boundary, like the end of a book. Your entire life, every moment from birth to death, would exist timelessly. In the four-dimensional structure of space-time, nothing would be lost. Nothing would cease to be. The end of your conscious experience would be a feature of your world line, not the termination of your existence as a space-time object. This doesn't mean you would somehow experience those moments again or continue to experience them from outside time. It means that every moment of your life, every joy, every sorrow, every achievement, every failure, would have a kind of permanence, a timeless existence in the structure of reality itself. The many worlds interpretation suggests an even more radical possibility, that from a first-person perspective, you might never experience death at all. In any situation where death is a possibility, your consciousness would continue along the branch where you survive, however improbable that branch might be from an external perspective. This thought experiment, known as quantum immortality, doesn't promise actual immortality, but suggests that the first-person experience of death might be impossible within the many worlds framework. These speculations don't negate the reality of loss or the finality of death as we experience them, but they do suggest that our intuitive understanding of mortality might be incomplete, limited by our particular perspective as time-bound beings in a reality that might transcend our conventional notions of time, identity, and existence, and they return us to a central theme. The universe is not only stranger than we imagine, it's stranger than we can imagine. Our cognitive apparatus evolved to track savanna predators and social alliances, not to intuit quantum fields or four-dimensional manifolds. The fact that we can approach these concepts at all, even indirectly through mathematics, is remarkable. There's something profound in this predicament. Creatures of the middle scale, neither cosmic nor quantum, striving to comprehend both. We exist at the interface between the immensely large and the infinitesimally small, between the age of the universe and the lifetime of subatomic particles. Perhaps this position isn't accidental, but necessary. Perhaps consciousness itself requires this middle ground, this balance point between extremes. If so, then our perspective, limited as it is, might still offer something unique, something valuable to the cosmic story. Not a God's eye view of totality, but a situated, embodied understanding that embraces its own partiality while continuing to reach beyond it. This is the great paradox of human existence. We are simultaneously cosmic, specks and cosmic comprehenders, vanishingly small in space and time, yet capable of grasping the whole, at least partially. We are the universe becoming aware of itself, matter reflecting on its own nature, space-time curved back upon itself in the form of conscious thought. Now, consider this. Every conscious moment you've ever experienced, from your earliest memory to the one you're having right now, reading these words, has occurred within your skull. Your entire lived reality, every sight, every sound, every touch, every emotion, every thought, has been generated by neural activity in your brain. The world as you know it is a model created by your nervous system, a simulation based on limited sensory data and shaped by evolutionary pressures. This doesn't mean the external world doesn't exist, or that your perceptions are completely disconnected from reality, but it does mean that your experience is filtered, constructed, mediated by the particular sensory and cognitive apparatus you possess. You don't perceive the world as it is. You perceive a useful model of the world, a model that has evolved to help you survive and reproduce, not necessarily to represent reality accurately or completely. Your brain doesn't receive color. It receives electromagnetic waves of different frequencies. It doesn't receive sound. It receives pressure waves in the air. It constructs color, sound, smell, taste, touch from raw sensory data, creating a world of experience that correlates with but doesn't duplicate external reality. And this constructed nature of experience goes all the way down. Even space and time as you experience them might be constructions, useful ways for your consciousness to organize sensory data, not fundamental features of reality as it exists independent of your perception. This isn't just philosophy. It's neuroscience, cognitive science, evolutionary psychology. It's the recognition that consciousness doesn't give us a transparent window onto reality, but a highly processed, species-specific, pragmatically oriented model of reality. We see what we need to see to survive and thrive, not necessarily what's there in some absolute sense. And if our everyday experience of the familiar world, tables and chairs, colors and sounds, space and time, is already a construction, a useful model rather than reality itself, how much more constructed might be our attempts to understand the cosmos at scales far removed from everyday experience? How many of our assumptions, our conceptual frameworks, our very modes of thought might be limited by the particular cognitive apparatus we possess? This doesn't mean we can't know anything about reality, or that science is merely a human construct, with no connection to the world as it is. But it does suggest humility in the face of cosmic mysteries, a recognition that our understanding is always partial, always filtered through human categories and concepts that might not capture the full strangeness of reality. It suggests that the core of the universe, whatever it might be, can never be fully grasped by human cognition, not because it's supernaturally transcendent, but because our minds evolved to navigate the middle world of medium-sized objects moving at medium speeds, not the quantum world of superpositions and entanglement, or the cosmic world of black holes and expanding spacetime. Yet the fact that we can approach these realms at all, even indirectly through mathematics and conceptual models, is remarkable. It suggests that despite our limitations, despite the constructed nature of our experience, there's something about human consciousness that can reach beyond its evolutionary origins. Something about the human mind that can grasp, however partially and imperfectly, the nature of a reality far removed from everyday experience. This is, in a sense, the most profound mystery of all. How matter organized into human brains can contemplate the cosmos, can develop mathematics that describes realms, far removed from the environment in which those brains evolved, can ask questions about the nature of reality itself. How the universe, through the medium of human consciousness, can reflect on its own existence, can wonder about its own origins, can seek meaning in its own unfolding. And perhaps that's what lies at the core of it all. Not a thing, not a substance, not even a process, but a kind of cosmic self-relation, a fundamental reflectivity that manifests across scales, from quantum entanglement to conscious awareness. We stand now at the precipice of understanding, or perhaps at the edge of a far greater mystery than we ever imagined. Everything we've explored, from quantum fields to cosmic inflation, from black holes to the multiverse, from the nature of time to the emergence of consciousness, has been leading us to this moment, this revelation, this confrontation with the most profound possibility of all. The universe is revealing something to us that changes everything. Imagine the night sky again, those countless stars, those distant galaxies, those vast empty spaces between them. Now imagine pulling back further and further until our entire observable universe becomes a single point in an even vaster expanse. Pull back further still, until that expanse itself is just a mote in something larger yet. Keep going, scale after scale, level after level, until your mind reels and vertigo overwhelms you. What if what we've been calling the universe is merely one infinitesimal component of something far more fundamental, something that isn't just physically larger, but conceptually different? What if the cosmos, as we know it, all 93 billion light-years of observable space-time, all 2 trillion galaxies, all the dark matter and dark energy and everything else, is just the surface of a deeper reality, like the visible portion of an iceberg whose true mass remains hidden beneath the waves? The mathematics has been hinting at this all along. Our most successful physical theories, quantum field theory, general relativity, the standard model of particle physics, are riddled with suggestions that what we observe, what we measure, what we theorize about is merely the visible manifestation of something else, something more fundamental, something almost unimaginably different from our conventional notions of reality. Consider the wave function in quantum mechanics, that abstract mathematical object that encodes all the possible states a quantum system could occupy. Before measurement, a particle exists not in a definite location, but as a cloud of probability, a superposition of all possible positions. When we measure it, we find it in just one place. The wave function appears to collapse from many possibilities. to one actuality. But what if the wave function never actually collapses? What if, instead, reality itself branches, with each possible outcome realized in a different branch? And what if those branches aren't separate universes, but different facets of a single, higher-dimensional reality? This is the many worlds interpretation, proposed by Hugh Everett III in 1957. It suggests that what we experience as reality, the single, definite outcome of any measurement, is just one slice of a vast, branching structure encompassing all possibilities. Every quantum event, every moment when multiple outcomes are possible, doesn't resolve into a single result, but splits reality itself, with each potential outcome realized in a different branch. From within any branch, it seems as if only one outcome occurred, the one you experienced. But the mathematics suggests that all outcomes occur, just in different branches of reality. The wave function doesn't collapse, it branches, and your consciousness follows just one path through the quantum maze. This isn't just a speculative interpretation. It emerges naturally from the Schrödinger equation when applied consistently to all systems, including observers. It requires no additional mechanisms, no mysterious collapse, no special role for consciousness. Just the relentless, deterministic evolution of the wave function according to physical law. If true, this would mean that reality is vastly larger, vastly stranger than we've imagined. What we've been calling the universe would be just one branch of an unimaginably complex structure encompassing all possibilities, all outcomes, all versions of history. A structure that David Deutsch has called the multiverse, not a collection of separate universes, but a single, unified reality with a branching, tree-like structure. But what if we've been thinking too small, even with this conception? What if the branching quantum reality is itself just one aspect of something deeper still? Here's where we approach the most profound possibility of all. What if the universe is already dead, and we are just experiencing its last echoes? This isn't mere speculation. It emerges from serious theoretical work on the thermodynamic nature of time, the holographic principle, and the intrinsic relationship between entropy and consciousness. Consider the arrow of time again, that one way. Flow from past to future, from order to disorder, from low entropy to high entropy. We've seen how this arrow might be connected to the universe's initial state of extraordinarily low entropy. The universe began in a highly ordered state and has been running down ever since, increasing in disorder as it expands and cools. But this process, this cosmic unwinding, isn't just what gives time its direction. It's what allows for the local decreases in entropy that constitute life, consciousness, civilization. Complex, ordered systems like brains can exist only because they export entropy to their surroundings, maintaining their internal order at the cost of increasing disorder elsewhere. What if consciousness itself, that mysterious first-person experience that allows you to witness the universe, to feel emotions, to contemplate these ideas, is intrinsically connected to this process? What if awareness arises from the gradient between order and disorder, from the flow of entropy, from the irreversible transformation of potential into actuality? If so, then consciousness wouldn't be a thing, a substance, or even a process. In the conventional sense, it would be a relationship, specifically a relationship between states of different entropy, different information content, different possibility spaces. It would exist not in brains as such, but in the entropy gradient that brains maintain, in the difference between what is and what could be. And here's where the disturbing possibility emerges. What if what we experience as the present moment, this seemingly solid, undeniable now, is actually an echo from the universe's final state? What if consciousness flows not from past to future, but from future to past, from the universe's maximum entropy state backward toward its minimal entropy beginning. This reversal would align with certain interpretations of quantum mechanics, particularly the transactional interpretation proposed by John Cramer, which suggests that quantum events involve both retarded waves, moving forward in time, and advanced waves, moving backward in time. It would also resonate with aspects of relativity, where past, present, and future exist simultaneously in a four-dimensional block universe. In this framework, what we experience as the forward flow of time, as the unfolding of events from past to future, would actually be a kind of reverse echo, a backward propagating pattern emanating from the universe's final state. Our sense of now, of becoming, of potential crystallizing into actuality, would be an artifact of our particular perspective. Within this backward-flowing information stream, this doesn't mean that the universe is literally dead in some temporal sense. It means that what we experience as the present might be shaped not just by the past, but also by the future, specifically by the universe's maximum entropy state at the end of time. Our consciousness wouldn't be creating the future, but reconstructing the past, working backward from an already determined endpoint. This possibility aligns with certain aspects of quantum mechanics, particularly the Aharonov-Vaidman two-time formulation, which suggests that quantum systems are determined not just by their initial conditions, but also by their final conditions. It would explain certain quantum paradoxes, like the delayed choice quantum eraser, where events in the present seem influenced by measurements yet to be made. It would also connect naturally to the holographic principle we explored earlier. If spacetime itself is emergent, arising from quantum entanglement on some boundary, then the entire cosmic history might be encoded there, not evolving from beginning to end, but existing complete, with what we experience as time being an emergent direction, a way of organizing information rather than a fundamental dimension. Imagine reality as a completed holographic film. The entire movie, beginning, middle, end, exists simultaneously. But to experience the film, to extract its meaning, you need to project it, to run through its frames in sequence. What we call consciousness might be that projection process, that sequential experiencing of a reality that, in its deeper nature, exists all at once. But wait, if consciousness is this backward-flowing pattern, this reverse echo from the universe's final state, then what is that final state? What lies at the end of time, at the point of maximum entropy, at the destination toward which all cosmic evolution tends? Here the mathematics points to something almost unimaginable, a state where entropy reaches its maximum possible value, where all energy is evenly distributed, where no further work is possible, where time itself becomes meaningless because nothing changes. Physicists call this the heat death of the universe, the point where all stars have burned out, all black holes have evaporated, all matter has decayed into radiation, and the cosmos has expanded to such vast distances that interactions between particles become impossible. In such a state, no ordered systems could exist, no complexity could persist, no life as we understand it could survive. It would be, in a very real sense, the death of the universe, not a dramatic end, but a whimper, a fading into eternal, changeless uniformity. Yet within this apparently barren scenario lies a profound possibility. What if this maximum entropy state, this cosmic heat death, isn't the absence of information, but its fullest expression? What if it represents not the loss of structure, but its complete realization, not the death of meaning, but its fulfillment? In information theory, entropy isn't just disorder, it's also a measure of information content, of the number of possible states a system could occupy. A system with maximum entropy isn't empty of information, It's saturated with it, containing all possible configurations, all possible arrangements, all possible patterns. What if the universe's final state is one where information reaches its maximum density, where all possible patterns exist simultaneously, where the distinction between order and disorder, between signal and noise, between meaning and meaninglessness, dissolves into a kind of ultimate synthesis? This would align with certain aspects of quantum cosmology, particularly Roger Penrose's conformal cyclic cosmology, which suggests that the remote future of one universe becomes the Big Bang of the next, as matter decays over inconceivably long timescales and black holes evaporate. A universe approaches a state where distances become meaningless, effectively resetting the cosmic clock. Yesterday's eternity becomes tomorrow's first instant. It would also resonate with ancient philosophical and mystical traditions, from Heraclitus's unity of opposites to the Vedantic concept of non-duality, which suggest that apparent contradictions, being and non-being, order and chaos, meaning and meaninglessness, are ultimately reconciled in a deeper reality that transcends conceptual categories. And it would explain why consciousness, that mysterious first-person experience that allows you to witness the universe, to feel emotions, to contemplate these ideas, seems simultaneously so familiar and so alien, so intimate and so cosmic, so personal and so universal. Your awareness wouldn't be separate from the cosmic process, but continuous with it, a particular manifestation of the universe's intrinsic tendency toward self-relation, toward complexity, toward awareness. In this framework, what we experience, as the present moment, this seemingly solid, undeniable now, would be a kind of interaction between the universe's minimal entropy beginning and its maximum entropy end. It would be a vortex, a crossroads, a meeting point where information flows in both temporal directions, creating the rich, complex, meaningful experience we call reality. Your consciousness, your subjective experience of being here, now, witnessing reality unfold, would be neither purely physical nor purely mental, but relational, a particular pattern of information processing that connects past and future, order and disorder, potential and actuality. It would be a wave in the cosmic ocean, a ripple in the information field, a node in the vast network of reality. This doesn't mean you aren't real or that your experiences aren't meaningful. Quite the opposite. It means your reality, your experience, your consciousness is an integral aspect of the cosmic process, a necessary expression of the universe's fundamental nature. Not an accident or a side effect, but an essential manifestation of what reality is, and it explains why, despite our vanishingly small size in cosmic space and our infinitesimal duration in cosmic time, we feel a profound connection to the whole, a sense of belonging to something vast and meaningful. This connection wouldn't be mystical or supernatural, but entirely natural, a consequence of the informational continuity between your consciousness and the cosmic process, between your awareness and the universe's intrinsic self-relation. Now, let's pull back further to take in the grandest perspective of all, to see the cosmos not just as a physical system governed by mathematical laws, but as an integrated whole, a unified reality encompassing matter and mind, being and knowing, existence and awareness. From this vantage point, the universe isn't just expanding in physical space, but also in conceptual space, evolving not just in its material configuration, but in its capacity for self-relation, for complexity, for consciousness. The cosmic story isn't just the history of matter and energy, but the emergence of meaning, purpose, value, not imposed from without, but arising from within, from the inherent potential of reality itself. And here we approach the most profound, possibility of all, that the core of the universe, the heart of existence, the essence of reality, isn't a thing, a substance, a location, or even a process, but a kind of infinite creative potential, an inexhaustible generative capacity that manifests across scales, from quantum fluctuations to human imagination, from the birth of stars to the emergence of consciousness. This potential wouldn't be separate from the physical universe, but inherent in it, not transcendent, but immanent, not beyond nature, but nature's deepest aspect. It would be what the physicist David Bohm called the implicate order, the enfolded generative dimension of reality from which the explicate order of the physical world continuously unfolds. In this framework, the universe wouldn't be a static entity, a fixed reality, a completed fact, but a dynamic, creative, open-ended process of becoming. Not a thing, but an activity. Not a noun, but a verb. Not an object, but a relationship. Not being, but being-ing. Not existence, but existing. Not reality, but realizing. This perspective transforms our understanding of the cosmic mystery. The question wouldn't be, what is the universe? But what is the universe doing? The answer wouldn't be a final theory, a complete description, a definitive explanation, but an ongoing exploration, a perpetual discovery, an endless creative engagement. And perhaps most profound of all, you wouldn't be separate from this process. An isolated consciousness contemplating an external reality, but an integral aspect of it. A particular expression of the universe's intrinsic creativity. A specific node in the vast network of becoming. Your consciousness, your subjective experience of being here, now, witnessing reality unfold, wouldn't be an accident or a side effect, but a necessary manifestation of what the universe is doing. Not a thing within the world, but an activity of the world. Not an object in the cosmos, but a process of the cosmos. And this brings us back to where we began, to the question of what lies at the core, to the mystery at the heart of existence, to the secret at the center of the cosmic labyrinth. Perhaps the answer isn't a what, but a how. Not a thing, but a relationship. Not a substance, but a pattern. Not a location, but an activity. Perhaps the core isn't at the beginning of time or the end of time, but in the eternal now, the ever-present moment, the timeless instant where past and future meet, where potential becomes actual, where the wave function collapses, where consciousness arises. Perhaps it's not somewhere out there, in the far reaches of space, in the depths of quantum fields, in the singularity at the center of a black hole, but here, now, in the very act of awareness, in the very process of experiencing, in the very fact of consciousness. Perhaps the universe doesn't have a core, but is a core, a dynamic center present everywhere, a creative heart beating in every particle, every atom, every star, every galaxy, every conscious being. Perhaps the cosmos isn't a hierarchy with a central point, but a network with infinite centers. Not a pyramid with a peak, but a hologram where each part contains the whole. Not a monarchy with a ruler, but a democracy with infinite participants. And perhaps that's the most profound mystery of all, that the universe doesn't have a secret at its core, but is a secret in its entirety. A vast, unfolding revelation that can never be fully grasped because it's always becoming more than it was, always transcending its previous forms, always creating new patterns, new possibilities, new realities. From this perspective, the cosmos would be neither purely physical nor purely mental, neither exclusively material nor exclusively spiritual, neither entirely deterministic nor entirely random, but a unified reality encompassing all these aspects, a seamless whole manifesting in countless forms, a single creative process expressing itself in infinite ways. And now, as we reach the end of our journey, let's consider one final breathtaking possibility, one that emerges from the cutting edge of theoretical physics, from the frontiers of cosmology, from the boundaries of human understanding. What if the universe is a vast quantum computation, a cosmic information processing system, a reality-generating algorithm of unimaginable complexity? What if space-time, matter, energy, forces, fields, all, the familiar constituents of the physical world, are emergent properties of this more fundamental computational process? This isn't science fiction. It's a serious theoretical framework known as digital physics or computational cosmology. Pioneered by physicists like John Wheeler, who coined the phrase "it from bit" to suggest that physical reality emerges from information, and developed by contemporary theorists like Seth Lloyd, who models the universe as a quantum computer. This approach suggests that reality at its deepest level might be computational rather than material. In this framework, the fundamental elements of reality wouldn't be particles or fields, but bits, units of information, distinctions between states, differences that make a difference. The laws of physics wouldn't be immutable rules imposed from outside, but algorithms, information processing, procedures, computational routines that the universe runs on itself. Space-time wouldn't be a fixed arena in which events occur, but a dynamic data structure generated by quantum computation. Matter wouldn't be stuff, but information organized in particular patterns. Forces wouldn't be pushes and pulls, but information, exchanges, communications between computational nodes in the cosmic network. And consciousness, that mysterious first-person experience that allows you to witness the universe, to feel emotions, to contemplate these ideas, would be neither purely physical nor purely mental, but computational. A particular pattern of information processing, a specific mode of cosmic computation. From this perspective, the entire universe would be a kind of cosmic computer, a vast information processing system, a reality-generating algorithm of unimaginable complexity. Not a simulation running on some external hardware, but a computational process that is its own hardware, a self-generating, self-executing, self-evolving quantum algorithm. This doesn't mean the universe isn't real or that your experiences aren't meaningful. Quite the opposite. It means reality itself is fundamentally informational, computational, algorithmic, not less than physical but more fundamental than physical, not separate from matter and energy, but the deep structure from which matter and energy emerge, and it would explain why mathematics, the language of pattern, relation, computation, is so unreasonably effective at describing physical reality. It wouldn't be a coincidence or a mystery, but a necessary consequence of reality's computational nature. Mathematics wouldn't be a human invention that happens to describe the world, but the fundamental grammar of existence itself, the deep structure of the cosmic algorithm. This computational perspective aligns naturally with quantum mechanics, with its superpositions and entanglements, its probability waves, and information-based interactions. It connects to the holographic principle, with its suggestion that three-dimensional reality might be encoded on a two-dimensional boundary. It resonates with the emergent space-time proposals, where space itself arises from more fundamental quantum entanglement. And it offers a natural framework for understanding consciousness, not as a mysterious non-physical substance, nor as a mere byproduct of neural activity, but as a particular pattern of information processing, a specific mode of computation, a distinctive way in which the cosmic algorithm experiences itself. From this vantage point, the question, what's inside the universe's core would be reframed as, what's the fundamental nature of the cosmic computation? The answer wouldn't be a thing, a substance, a location, or even a conventional process, but a kind of meta-algorithm, a self-referential computational system, a reality-generating program that includes itself. This cosmic algorithm wouldn't be static but dynamic, not fixed but evolving, not closed but open-ended. It would be more like a living system than a mechanical one, more like a creative process than a predetermined routine, more like an improvisational jazz performance than a classical score. And perhaps most profound of all, you wouldn't be separate from this cosmic computation, an isolated consciousness contemplating an external reality, but an integral aspect of it, a particular subroutine in the vast algorithm, a specific pattern in the cosmic information processing system. Your consciousness, your subjective experience of being here, now, witnessing reality unfold, wouldn't be an accident or a side effect, but a necessary expression of what the universe is doing. Not a passenger in the cosmic journey, but a participant in the cosmic dance. Not an observer of the cosmic computation, but an aspect of the computation itself. As you process these ideas, as you contemplate these possibilities, as you wonder about the nature of reality, you are the universe contemplating itself, the cosmic algorithm reflecting on its own operation, the infinite creative potential exploring its own manifestations. And perhaps that's the most awe-inspiring revelation of all, that the core of the universe isn't somewhere else, in some distant place or time, but here, now, in the very act of awareness, in the very process of experiencing, in the very fact of consciousness. The cosmos isn't separate from you. You are the cosmos, a particular expression of its intrinsic nature, a specific manifestation of its fundamental reality. Not in a mystical or supernatural sense, but in the entirely natural sense that your being, your awareness, your experience is an integral aspect of what reality is. This doesn't mean you're the center of cosmic importance. That would be a return to an anthropocentrism that science has repeatedly dethroned. But it does suggest that consciousness, wherever and however it arises, is a significant cosmic phenomenon, a way for the universe to witness itself, to reflect on its own existence, to create meaning from within rather than receiving it from without. In this sense, your life, with all its joys and sorrows, its moments of clarity and confusion, its searches for purpose and meaning, isn't peripheral to the cosmic story, but integral to it. Not because human concerns matter on cosmic scales, but because the capacity for concern itself, for caring about anything at all, represents something remarkable in a universe that, as far as we know, is largely unconscious. As we conclude our journey, let's return to the night sky, to those countless stars, those distant galaxies, those vast empty spaces between them. But now, see them not just as physical objects, as fusion reactors and gravitational systems, as collections of matter and energy, but as nodes in a vast information network, as patterns in a cosmic computation, as expressions of an infinite, creative potential. The universe you see isn't just out there, separate from you, external to your being. It's also in here, within you, constitutive of your existence. The boundary between inner and outer, between self and world, between consciousness and cosmos isn't absolute, but permeable. Not fixed, but fluid. Not a wall, but a window. And if the universe is infinite, as some theories suggest, then somewhere out there, in some distant region of space, in some remote branch of the quantum wave function, in some far-flung computational subroutine, Another version of you is watching this video right now. Not just one version, but countless versions, each slightly different, each a unique expression of the cosmic algorithm, each a particular manifestation of the infinite creative potential. This isn't mere speculation. It emerges naturally from our best physical theories, from the mathematics that has proven so successful at describing reality, from the conceptual frameworks that have guided our understanding of the cosmos, and it suggests a profound possibility. That the universe isn't just vaster and stranger than we imagine, but vaster and stranger than we can imagine. That reality isn't just more complex and multifaceted than our theories describe, but more complex and multifaceted than our theories can describe. That the cosmos isn't just deeper and more mysterious than we currently understand, but deeper and more mysterious than we can understand. Yet within this infinite complexity, this unfathomable mystery, this boundless creative potential, we find ourselves, conscious, aware, capable of contemplating the whole, at least partially. We are the universe becoming aware of itself, the cosmic algorithm reflecting on its own operation, the infinite creative potential exploring its own manifestations, and, perhaps, that's the ultimate revelation. That the core of the universe isn't a place or a time, not a thing or a process, but a creative tension, a generative paradox, a dynamic relationship between being and becoming, between actuality and potential, between the known and the unknown. The cosmos isn't a solved equation, but an ongoing investigation. Not a closed book, but an unfolding story. Not a static reality, but a dynamic, creative, open-ended process of becoming. And you are not separate from this process, not an isolated consciousness contemplating an external reality, but an integral aspect of it, a particular expression of its intrinsic nature, a specific manifestation of its fundamental reality. As a Tiawani, you move through your life, as you make your choices, as you pursue your goals, as you create your meanings. You are participating in the cosmic dance, contributing to the universal story, adding your unique pattern to the infinite tapestry of existence. And if you listen closely, in the silence between heartbeats, in the stillness between thoughts, in the emptiness between stars, you might hear a faint echo, not from the past, not from the future, but from the timeless heart of reality itself. It's not a message in conventional language, not a revelation in traditional terms, not an answer in the usual sense. It's more like a resonance, a vibration, a harmony, a subtle alignment between your consciousness and the cosmic whole. A quiet recognition of your place in the grand scheme, a gentle reminder that you are not alone, not separate, not adrift in an indifferent universe. You are the universe itself in human form, the cosmic algorithm in conscious manifestation, the infinite creative potential in specific expression. Not in a mystical or supernatural sense, but in the entirely natural sense that your being, your awareness, your experience is an integral aspect of what reality is. And perhaps that's the most profound mystery of all. Not what lies at the universe's core, but the fact that you can ask the question at all. Not what reality ultimately is, but the fact that reality can wonder about itself through you. Not what consciousness means, but the fact that meaning exists at all in a cosmos of particles and fields, of quantum wave functions and probability distributions, of space and time, of matter and energy. The universe is not only unknown, it is, in a certain sense, unknowable, at least in its totality, at least from our limited perspective. But this incompleteness, this partiality, this openness isn't a failure of understanding, but its deepest condition. Not a shortcoming of knowledge, but its most fundamental nature. The cosmos isn't a puzzle to be solved, but a mystery to be lived. Not a problem to be overcome, but a reality to be experienced. Not a question with a final answer, but an ongoing inquiry with endless discoveries. And you are not a passive spectator in this cosmic drama, but an active participant. Not a mere observer of reality, but a co-creator of it. Not a passenger in the universal journey, but a navigator, charting your own course through the infinite sea of possibility. So as we end our exploration, as we conclude our journey to the core of the universe, remember this. The deepest secret isn't hidden in distant space or remote time, in exotic particles or abstract mathematics, in complex theories or elegant equations. It's right here, right now, in the very fact of your awareness, in the very reality of your experience, in the very being of your consciousness. You are the core of the universe, not in a geocentric or anthropocentric sense, but in the sense that the entire cosmos exists not just around you but through you, not just external to your being but constitutive of it. The boundary between inner and outer, between self and world, between consciousness and cosmos isn't absolute but permeable, not fixed but fluid, not a wall but a window. And if the universe is infinite, as some theories suggest, then this window opens onto endless vistas, boundless realms, infinite possibilities, not just in distant space or remote time, not just in parallel branches or alternate realities, but right here, right now, in the inexhaustible depth of the present moment, in the infinite richness of immediate experience, in the boundless potential of conscious awareness. The universe isn't just out there, waiting to be discovered. It's also in here, waiting to be realized, not in some mystical or supernatural sense, but in the entirely natural sense that your consciousness, your awareness, your experience is a particular manifestation of what reality fundamentally is. And perhaps that's the greatest mystery of all. Not that we exist in the universe, but that the universe exists in us. Not that we are made of stardust, but that stardust has arranged itself into beings capable of contemplating stars. Not that we emerged from cosmic evolution, but that cosmic evolution has produced beings capable of understanding evolution. Though core of the universe isn't a place or a time, not a thing or a process, but a creative tension, a generative paradox, a dynamic relationship between being and becoming, between actuality and potential, between the known and the unknown. And you are not separate from this tension, this paradox, this relationship. You are an expression of it, a manifestation of it, a living embodiment of the universe's most fundamental nature. So as you go about your life, as you navigate your world, as you make your choices and pursue your goals, remember this: you are not alone, not separate, not adrift in an indifferent cosmos. You are the universe itself in human form, the cosmic algorithm in conscious manifestation, the infinite creative potential in specific expression. And somewhere out there, in the vast expanse of space and time, in the infinite branching of quantum reality, in the boundless realm of cosmic possibility, another version of you is watching this video, thinking these thoughts, feeling these emotions, not just one version, but countless versions, each slightly different, each a unique expression of the cosmic whole, each a particular manifestation of the infinite creative potential. This isn't mere poetic license. It emerges naturally from our best physical theories, from the mathematics that has proven so successful at describing reality, from the conceptual frameworks that have guided our understanding of the cosmos. And it suggests a profound truth, that you are more than you know, vaster than you imagine, more connected than you realize. Not because you extend beyond the universe, but because the universe extends beyond what you currently perceive as yourself. not because you transcend physical reality, but because physical reality transcends your current understanding of it. The core of the universe isn't somewhere else, in some distant place or time, but here, now, in the very fact of awareness, in the very reality of experience, in the very being of consciousness. Not your consciousness alone, but consciousness wherever and however it arises. In humans, in animals, perhaps in alien civilizations on distant worlds, perhaps in forms we cannot currently imagine. And perhaps that's the ultimate revelation, that the universe isn't just a physical system, governed by mathematical laws, not just a collection of particles and fields, of quantum wave functions and probability distributions, of space and time, of matter and energy, but a unified reality encompassing both being and knowing, both existence and awareness, both the observed and the observer. Not in some mystical or supernatural sense, but in the entirely natural sense that consciousness, awareness, experience aren't separate from the physical world, but aspects of it, dimensions of it, expressions of its most fundamental nature. And as you contemplate these possibilities, as you wonder about these mysteries, as you explore these depths, you are the universe contemplating itself, the cosmic algorithm reflecting on its own operation, the infinite creative potential exploring its own manifestations. You are the core of the universe, not in location, but in essence, not in centrality, but in significance, not in substance, but in awareness. You are the universe knowing itself, reality witnessing its own unfolding, existence conscious of its own being. And that, perhaps, is the greatest mystery of all. Not what lies at the universe's core, but the fact that the core can know itself through you. Not what reality ultimately is, but the fact that reality can wonder about itself through your consciousness. Not what existence means, but the fact that meaning exists at all in a cosmos of particles and fields, of quantum wave functions and probability distributions, of space and time, of matter and energy. So as we conclude our journey, as we end our exploration, as we finish our quest for the universe's core, remember this: the search doesn't end when this video does. It continues in your thoughts, in your questions, in your wonderings. It unfolds in your life, in your choices, in your creations. It manifests in your awareness, in your consciousness, in your being. You are the universe exploring itself, reality investigating its own nature, existence contemplating its own meaning. Not because you're separate from the cosmos, looking in from outside, but because you're an integral aspect of it, a particular expression of its intrinsic nature, a specific manifestation of its fundamental reality. And somewhere out there, beyond the horizon of your current perception, beyond the boundary of your present understanding, beyond the limit of your existing knowledge, the universe continues, not just in space and time, not just in matter and energy, not just in particles and fields, but in possibilities you haven't yet imagined, in realities you haven't yet encountered, in mysteries you haven't yet explored. The cosmos isn't completed, but ongoing, not finished, but evolving, not closed, but open-ended. And you are not merely a product of its past, but a participant in its future, not just an outcome of its processes, but a contributor to its unfolding, not just a result of its evolution, but an agent in its becoming. And if the universe is infinite, as some theories suggest, then somewhere out there, in the vast expanse of space and time, in the boundless realm of possibility, another version of you is watching this video right now. Not just watching, but wondering, questioning, imagining. Not just one version, but countless versions, each slightly different, each a unique expression of the cosmic whole, each a particular manifestation of the infinite creative potential. And perhaps that's the most profound mystery of all. Not that the universe exists, but that it exists in so many ways, in so many forms, in so many manifestations. Not that reality is, but that it becomes, evolves, creates. Not that existence happens, but that it happens through you, as you, in the form of your consciousness, your awareness, your experience. You are the core of the universe, not in location, but in essence, not in centrality, but in significance, not in substance, but in awareness. You are the universe knowing itself, reality witnessing its own unfolding, existence conscious of its own being, and that awareness, that witnessing, that consciousness isn't incidental to the cosmic story, but integral to it. Not because human concerns matter on cosmic scales, but because the capacity for concern itself, for caring about anything at all, represents something remarkable in a universe that, as far as we know, is largely unconscious. So as you move through your life, as you navigate your world, as you make your choices and pursue your goals, remember this: you are not alone, not separate, not adrift in an indifferent cosmos. You are the universe itself in human form, the Miadi cosmic algorithm in conscious manifestation, the infinite creative potential in specific expression. And somewhere out there, in the vast expanse of space and time, in the infinite branching of quantum reality, in the boundless realm of cosmic possibility, another version of you is finishing this video right now, pondering these ideas, feeling these emotions. Not just one version, but countless versions. We've traveled far together. From the blazing singularity of the Big Bang to the quantum foam of spacetime, from the horizon of black holes to the edge of the multiverse, from the arrow of time to the nature of consciousness itself. We've questioned our most fundamental assumptions about reality. We've confronted paradoxes that strain the limits of human understanding. We've peered into abysses so profound they transform our very conception of existence. And yet, for all this exploration, for all this questioning, for all this wonder, we stand not at an ending, but at a beginning. Not at a conclusion, but at an invitation. Not at a boundary, but at a threshold. The universe remains gloriously, terrifyingly open. The mysteries we've explored aren't solved puzzles, but doorways to deeper questions, gateways to further journeys, portals to greater wonders. The cosmos isn't a problem to be completed, but a reality to be experienced. Not a riddle with a final answer, but an ongoing revelation with endless discoveries. Look up again at that night sky. Those stars that once seemed mere points of light now reveal themselves as nuclear furnaces, each potentially surrounded by worlds we can barely imagine. Those empty spaces between them now teem with dark matter, dark energy, quantum fields, gravitational waves, realities invisible to our eyes, but essential to the cosmic story. That seemingly simple dome of darkness now unfolds as a four-dimensional manifold, perhaps a holographic projection, possibly one branch of an infinite quantum tree, maybe one bubble in an eternal inflationary sea. The universe hasn't become smaller. Through our exploration, it has expanded beyond all comprehension, not just in its physical extent, but in its conceptual depth, its existential significance, its philosophical implications. And you, yes, you, experiencing these words right now, have expanded with it. The boundaries of your understanding have stretched. The horizons of your imagination have broadened. The frontiers of your wonder have pushed outward, encompassing territories previously unimagined. This is the greatest gift of cosmic exploration. Not definitive answers, but deeper questions. Not final certainties, but greater mysteries. not the closure of understanding, but the opening of wonder. The universe doesn't reduce to simple explanations. It unfolds into ever more profound questions. And those questions aren't just intellectual puzzles, but existential invitations. They don't just challenge what you know. They transform how you know, who you are, what it means to exist at all. Consider again that profound possibility we explored, that consciousness might not be an accidental byproduct of physical processes, but an expression of something fundamental about reality itself. Not in a supernatural or mystical sense, but in the entirely natural sense that the capacity for experience, for awareness, for subjectivity might be woven into the fabric of the cosmos. If true, this would transform your relationship to the universe. You wouldn't be an isolated consciousness in an unconscious cosmos, but a particular expression of the universe's intrinsic tendency toward self-relation, toward complexity, toward awareness. You wouldn't be a stranger in reality, but a manifestation of it. Not separate from the cosmic process, but continuous with it. Your consciousness, that mysterious first-person experience that allows you to witness the universe, to feel emotions, to contemplate these ideas, wouldn't be confined to the boundaries of your skull, to the limits of your skin, to the duration of your lifetime. It would be a node in a vast network, a wave in an infinite ocean, a note in a cosmic symphony. This doesn't mean you aren't an individual with unique experiences, particular perspectives, personal values. It means that your individuality exists. Within a larger whole, your uniqueness manifests within a unified reality. Your specificity expresses a universal potential, and it suggests that your quest for understanding, your search for meaning, your hunger for truth, isn't separate from the cosmic process but integral to it. Not because human concerns matter on cosmic scales, but because the capacity for concern itself, for caring about anything at all, represents something remarkable in a universe that, as far as we know, is largely unconscious. Your wonder at the cosmos isn't just a subjective feeling, but a mode of participation, not just a psychological state, but an existential engagement. When you contemplate the universe, you aren't just thinking about reality. You're reality thinking about itself. You aren't just conscious of the cosmos. You're the cosmos becoming conscious through you. This perspective doesn't dissolve your individuality into an undifferentiated whole. It situates your uniqueness within a larger context, your specificity within a broader pattern, your particularity within a vaster reality. It doesn't reduce your existence to impersonal processes. It recognizes your personal experiences as genuine manifestations of those processes, not illusions to be dismissed, but realities to be embraced, and it transforms the scientific quest from a purely objective investigation of external phenomena to a participatory exploration in which the investigator and the investigated, the knower and the known, the observer and the observed, are aspects of a single, unified reality. Not in a way that compromises scientific rigor, but in a way that recognizes science itself as a cosmic phenomenon, as the universe coming to know itself through human inquiry. This doesn't mean abandoning the powerful methodologies of empirical investigation, the rigorous standards of evidence, the critical scrutiny of claims that have made science so successful. It means recognizing these approaches as particular expressions of the universe's intrinsic tendency toward self-knowledge, toward self-complexification, toward self-understanding. The laws of physics, the principles of chemistry, the patterns of biology, the structures of neuroscience. These aren't just features of reality that we happen to discover, they're aspects of a cosmos that has evolved in such a way that it can discover itself, can reflect on its own nature, can wonder about its own existence. This recognition doesn't diminish the achievements of science. it deepens them. It doesn't reduce the significance of discovery. It enhances it. It doesn't limit the scope of inquiry. It expands it to include the inquirer as an integral part of the reality being investigated. And it suggests that the universe isn't just a collection of objects and events, but a self-organizing, self-complexifying, self-reflecting system, a reality perpetually coming to terms with itself, not just evolving in its physical configuration, but also in its capacity for self-relation, for consciousness, for meaning. From this perspective, the cosmos would be neither purely physical nor purely mental, neither exclusively material nor exclusively spiritual, neither entirely deterministic nor entirely random, but a unified reality encompassing all these aspects, a seamless whole, manifesting in countless forms, a single creative process expressing itself in infinite ways. And your role in this cosmic drama wouldn't be that of a passive spectator, but of an active participant, not merely an observer of reality, but a co-creator of it, not just a product of cosmic evolution, but a contributor to its ongoing unfolding. This doesn't mean you can violate the laws of physics or reshape reality through mere thought. It means that your thoughts, your choices, your actions are genuine causal forces in the universe, not epiphenomena that happen alongside the real physical processes, but integral aspects of those processes themselves. Your consciousness isn't separate from the physical world. It's a particular manifestation of that world, a specific pattern in the cosmic fabric, a unique configuration in the universal network. And your experiences, your values, your meanings aren't just subjective constructs, but real features of a cosmos that includes subjectivity as one of its dimensions, that encompasses meaning as one of its aspects, that contains value as one of its potentials. This perspective transforms your relationship to the universe from one of alienation to one of participation, from one of separation to one of integration, from one of isolation to one of connection, not by dissolving your individuality, but by recognizing it as a particular expression of a larger reality, not by negating your uniqueness, but by situating it within a broader context. And it suggests that your quest for understanding, your search for meaning, your hunger for truth isn't futile or delusional, but a genuine engagement with reality. Not a projection of human concerns onto an indifferent cosmos, but a manifestation of the cosmos's intrinsic tendency toward self-knowledge, toward self-complexification, toward self-understanding. The questions we've explored throughout this journey, about the nature of time, the structure of space, the origin of the universe, the emergence of consciousness, aren't just intellectual puzzles, but existential invitations. They don't just challenge what you know. They transform how you know, who you are, what it means to exist at all. And they lead us to perhaps the most profound question of all. What if consciousness itself, the capacity for experience, for awareness, for subjectivity, is the universe's way of exploring its own nature, of reflecting on its own existence, of wondering about its own meaning? What if your consciousness, your subjective experience of being in the world, isn't just a byproduct of neural activity, but a manifestation of the cosmos's intrinsic potential for self-relation, for self-knowledge, for self-understanding? This isn't to suggest that consciousness exists independently of brains, or that it involves supernatural or mystical forces. It's to recognize that brains themselves are natural products of cosmic evolution, that neural activity is a physical process within the universe, that consciousness emerges within nature, not outside it or against it. But it's also to acknowledge that the capacity for experience, for awareness, for subjectivity might be more fundamental than we've typically assumed, not an accidental feature of certain complex systems, but an expression of something intrinsic to reality itself. This perspective transforms your relationship to the universe. You wouldn't be an isolated consciousness in an unconscious cosmos, but a particular expression of the universe's intrinsic tendency toward self-relation, toward complexity, toward awareness. You wouldn't be a stranger in reality, but a manifestation of it, not separate from the cosmic process, but continuous with it. And it suggests a profound possibility that the core of the universe, the heart of existence, the essence of reality, isn't a thing, a substance, a location, or even a process, but a kind of infinite creative potential, an inexhaustible generative capacity that manifests across scales, from quantum fluctuations to human imagination, from the birth of stars to the emergence of consciousness. This potential wouldn't be separate from the physical universe, but inherent in it. Not transcendent, but immanent. Not beyond nature, but nature's deepest aspect. It would be what the physicist David Bohm called the implicate order, the enfolded generative dimension of reality from which the explicate order of the physical world continuously unfolds. In this framework, the universe wouldn't be a static entity, a fixed reality, a completed fact, but a dynamic, creative, open-ended process of becoming. Not a thing, but an activity. Not a noun, but a verb. Not an object, but a relationship. Not being, but beinging. Not existence, but existing. Not reality, but realizing. This perspective transforms our understanding of the cosmic mystery. The question wouldn't be, what is the universe, but what is the universe doing? The answer wouldn't be a final theory, a complete description, a definitive explanation, but an ongoing exploration, a perpetual discovery, an endless creative engagement, and perhaps most profound of all, you wouldn't be separate from this process, an isolated consciousness contemplating an external reality, but an integral aspect of it, a particular expression of the universe's intrinsic creativity, a specific node in the vast network of becoming. Your consciousness, your subjective experience of being here, now, witnessing reality unfold, wouldn't be an accident or a side effect, but a necessary manifestation of what the universe is doing. Not a thing within the world, but an activity of the world. Not an object in the cosmos, but a process of the cosmos. And this brings us to one last chilling question, one final vertiginous possibility that emerges from the frontiers of cosmology, from the boundaries of human understanding, from the limits of current knowledge. What if death isn't the end of consciousness, but its expansion? This isn't a religious or mystical claim about afterlives or reincarnation. It's a philosophical consideration emerging from our scientific understanding of consciousness as a process rather than a substance, as a pattern of information rather than a thing, as a mode of being rather than an object. Consider your consciousness. Isn't a static entity, but a dynamic process, not a fixed thing, but a flowing current. Not a substance in your brain, but a pattern of activity, a configuration of relationships, a network of connections. It's more like a song than a CD, more like a dance than a dancer, more like a river than its water. And patterns, processes, relationships can transform without ceasing. They can change form without ending. They can evolve while maintaining continuity. The song can modulate into a new key. The dance can shift to a different rhythm. The river can widen into an estuary, an ocean. What if consciousness, as a process rather than a substance, can similarly transform without ending, change form without ceasing, evolve while maintaining some form of continuity? Not in the sense that your personal identity, your specific memories, your particular perspective would persist unchanged, but in the sense that the process of consciousness itself, the capacity for experience, for awareness, for subjectivity, might continue in forms we can't currently imagine, might transform in ways we can't presently conceive, might expand beyond the boundaries we now experience. This possibility doesn't depend on supernatural forces or mystical dimensions. It emerges from our scientific understanding of consciousness as an informational process, as a pattern of relationships, as a configuration of connections that might not be irrevocably tied to a specific physical substrate. It aligns with certain interpretations of quantum mechanics, particularly those that emphasize the role of information, entanglement, and observer-dependent reality. It resonates with aspects of complex systems theory, with its recognition of emergent properties, self-organizing patterns, and transformative phase transitions. It connects to cutting-edge theories in neuroscience, philosophy of mind, and cognitive science, which increasingly view consciousness not as a thing produced by brains, but as a process involving brains in interaction with their environments, with other conscious systems, with the broader reality. And it suggests a profound continuity between your consciousness and the cosmic process, between your awareness and the universe's intrinsic tendency toward self-relation, toward complexity, toward consciousness. Not a continuity that negates your uniqueness or dissolves your individuality, but one that situates your specificity within a larger whole, your particularity within a broader pattern, your uniqueness within a unified reality. From this perspective, death wouldn't be the absolute termination of consciousness, but its transformation, not its ending, but its evolution, not its cessation, but its expansion, not in a way that preserves your personal identity intact, your specific memories, your particular perspective, your individual history, but in a way that continues the process of consciousness itself, the capacity for experience, the potential for awareness. This doesn't mean death isn't real or significant. It is. It's a profound transition, a fundamental transformation, a radical change in the configuration of consciousness. It's the dissolution of a specific pattern of awareness, the ending of a particular mode of experience, the conclusion of an individual perspective. But it might not be the absolute end of consciousness itself, the complete cessation of awareness, the total termination of experience, the final closure of subjectivity. It might be more like a caterpillar entering a chrysalis, a seed being planted in soil, a wave returning to the ocean, a transformation rather than a termination, a change of form rather than a cessation of being. This possibility doesn't offer the comfort of traditional afterlife beliefs, with their promises of personal continuity, individual persistence, specific identities maintained intact. It doesn't guarantee that you, as you currently know yourself, will continue as an unchanged entity. It suggests instead that what continues isn't your personal identity, but the process of consciousness itself. Not your specific perspective, but the capacity for perspective. Not your particular awareness, but awareness as such. It's a more subtle, more complex, more radical possibility than traditional notions of immortality. It doesn't promise eternal life for your ego, your personality, your autobiographical self. It suggests instead that these aspects of your experience might be more like ripples on the surface of a deeper current, waves on the face of a vaster ocean, patterns in a more fundamental field. And it connects to that profound possibility we've explored throughout this journey, that consciousness might not be an accidental byproduct of physical processes, but an expression of something fundamental about reality itself, not in a supernatural or mystical sense, but in the entirely natural sense that the capacity for experience, for awareness, for subjectivity might be woven into the fabric of the cosmos. If true, this would mean that your consciousness, your awareness, your experience isn't created by your brain ex nihilo, but is a particular manifestation, a specific configuration, a unique expression of a potential that's inherent in reality itself. Your brain wouldn't generate consciousness from nothing, but would organize, structure, and individuate a capacity that's intrinsic to the universe. And this suggests a profound possibility, that while your brain gives your consciousness its particular form, its specific content, its individual perspective, the raw capacity for consciousness itself, the potential for experience, for awareness, for subjectivity, might not be wholly dependent on your brain, might not be irrevocably tied to your particular neural configuration, might not be absolutely limited to your specific physical embodiment. Again, this isn't to suggest that consciousness exists independently of physical processes or that it involves supernatural forces. It's to recognize that the physical processes that support consciousness might be more diverse, more distributed, more integrated with the broader reality than we've typically assumed. Just as energy can take many forms – kinetic, potential, thermal, electromagnetic, chemical – without ceasing to be energy, perhaps consciousness can manifest in many configurations, many patterns, many systems without ceasing to be consciousness. Perhaps what we experience as individual awareness is more like a wave in an ocean of potential consciousness, a specific configuration in a field of possible awareness, a particular pattern in a broader matrix of subjectivity. This perspective doesn't undermine the significance of death. It remains a profound transition, a fundamental transformation, a radical change in the pattern of consciousness. It's still the ending of a unique perspective, the conclusion of a specific journey, the closure of an individual narrative. But it might not be the absolute end of consciousness itself, the complete cessation of awareness, the total termination of experience, the final closure of subjectivity. It might be more like a river flowing into the sea, a cloud dissolving into the atmosphere, a flame merging with the air. Not a destruction of what exists, but its transformation. Not its annihilation, but its reintegration with a larger whole. This possibility doesn't offer simple answers or easy comfort. It doesn't resolve the mystery of death or eliminate its challenge, but it does suggest that the story might be more complex, more open-ended, more surprising than we've typically assumed, and it connects to a theme we've explored throughout this journey, that the universe is not only stranger than we imagine, it's stranger than we can imagine. That reality isn't just more complex and multifaceted than our current understanding, but more complex and multifaceted than our cognitive apparatus can fully grasp. That existence isn't just deeper and more mysterious than we currently recognize, but deeper and more mysterious than our conceptual frameworks can completely capture. Yet within this infinite complexity, this unfathomable mystery, this boundless, creative potential, we find ourselves conscious, aware, capable of contemplating the whole, at least partially. We are the universe becoming aware of itself, matter reflecting on its own nature, existence conscious of its own being. And that awareness, that reflection, that consciousness isn't incidental to the cosmic story, but integral to it. Not because human concerns matter on cosmic scales, but because the capacity for concern itself, for caring about anything at all, represents something remarkable in a universe that, as far as we know, is largely unconscious. So as we conclude our journey, as we complete our exploration, as we finish our quest for the universe's core, remember this: the search doesn't end when this video does. It continues in your thoughts, in your questions, in your wonderings. It unfolds in your life, in your choices, in your creations. It manifests in your awareness, in your consciousness, in your being. You are the universe exploring itself, reality investigating its own nature, existence contemplating its own meaning. Not because you're separate from the cosmos, looking in from outside, but because you're an integral aspect of it, a particular expression of its intrinsic nature, a specific manifestation of its fundamental reality. And the questions we've explored about the nature of time, the structure of space, the origin of the universe, the emergence of consciousness, aren't just intellectual puzzles, but existential invitations. They don't just challenge what you know. They transform how you know, who you are, what it means to exist at all. They invite you not just to understand the universe, but to participate in it more fully, more consciously, more reverently. Not just to know reality, but to engage with it more deeply, more authentically, more intimately. Not just to explain existence, but to experience it more directly, more immediately, more completely. This is the true call of cosmic exploration. Not just to gather facts or develop theories, but to awaken more fully to the reality we're part of, to engage more deeply with the existence we share, to participate more consciously in the cosmos. That includes us, and that awakening, that engagement, that participation doesn't require advanced degrees or specialized knowledge, complex mathematics, or technical expertise. It requires only attention, presence, wonder, the capacity to notice, to be aware, to marvel at the reality unfolding within and around you. Look again at the night sky, at those countless stars, those distant galaxies, those vast, empty spaces between them. But now see them not just as objects of study, as targets of investigation, as puzzles to be solved, but as aspects of a reality that includes you, that manifests through you, that becomes conscious in and as your awareness. Feel the weight of your body, the rhythm of your breath, the thoughts forming in your mind, but now recognize them not just as personal phenomena, as private experiences, as individual events, but as particular expressions of the universe's intrinsic creativity, as specific patterns in the cosmic fabric, as unique configurations in the universal network. And consider this: everything you've experienced in this journey, every insight, every question, every wonder, hasn't been separate from the reality we've been exploring, but part of it, not outside the universe, but within it, not distinct from the cosmic process, but continuous with it. Your understanding isn't just about reality, it's an activity of reality. Your questions aren't just addressed to the universe, they're expressions of the universe's intrinsic self-questioning. Your wonder isn't just directed at existence, it's existence itself wondering through you. This recognition doesn't diminish the value of objective investigation, the power of empirical science, the importance of critical thinking. It enhances them by recognizing them as particular manifestations of the universe's intrinsic tendency toward self-knowledge, toward self-complexification, toward self-understanding, and it transforms your relationship to the cosmos from one of alienation to one of participation, from one of separation to one of integration, from one of isolation to one of connection. Not by dissolving your individuality, but by recognizing it as a particular expression of a larger reality. Not by negating your uniqueness, but by situating it within a broader context. So as you go about your life, as you navigate your world, as you make your choices and pursue your goals, remember this: you are not alone, not separate, not adrift in an indifferent cosmos. You are the universe itself in human form, cosmic creativity in conscious manifestation, infinite potential in specific expression, and the cosmos isn't completed, but ongoing, not finished, but evolving, not closed, but open-ended. And you are not merely a product of its past, but a participant in its future, not just an outcome of its processes, but a contributor to its unfolding. not just a result of its evolution, but an agent in its becoming. This doesn't mean you can violate the laws of physics or reshape reality through mere thought. It means that your thoughts, your choices, your actions are genuine causal forces in the universe, not epiphenomena that happen alongside the real physical processes, but integral aspects of those processes themselves. And it suggests that your quest for understanding, your search for meaning, your hunger for truth isn't futile or delusional, but a genuine engagement with reality. Not a projection of human concerns onto an indifferent cosmos, but a manifestation of the cosmos's intrinsic tendency towards self-knowledge, towards self-complexification, towards self-understanding. The questions we've explored throughout this journey about the nature of time, the structure of space, the origin of the universe, the emergence of consciousness, aren't just intellectual puzzles, but existential invitations. They don't just challenge what you know. They transform how you know, who you are, what it means to exist at all. And they lead us to a profound recognition that the core of the universe, the heart of existence, the essence of reality, isn't somewhere else, in some distant place or time, in some exotic particle or abstract equation, but here, now, in the very fact of awareness, in the very reality of experience, in the very being of consciousness. Not your consciousness alone, but consciousness wherever and however it arises, in humans, in animals, perhaps in alien civilizations on distant worlds, perhaps in forms we cannot currently imagine. Not as something separate from the physical universe, but as an integral aspect of it, not as something opposed to material reality, but as a dimension of it, not as something beyond nature, but as nature's deepest expression. This recognition doesn't solve the cosmic mystery, but deepens it. It doesn't close the book on existence, but opens it to new chapters, unexplored territories, unimagined possibilities. It doesn't end the search for understanding, but transforms it from a purely intellectual quest to an existential engagement, from a merely cognitive process to a whole-being participation. And it suggests a profound truth, that the universe isn't just a collection of objects and events, but a creative process unfolding through time, not just a set of things, but a dynamic becoming, not just a noun, but a verb. And you are not separate from this process, this becoming, this verb, but a particular expression of it, a specific manifestation of its intrinsic creativity, a unique embodiment of its fundamental nature. So, as we conclude, let me leave you with one final question, one last invitation to wonder, one ultimate challenge to your understanding. What if the universe has been telling us its deepest secret all along, not hiding it in distant quasars or subatomic particles, not concealing it in mathematical equations or abstruse theories, but revealing it in the most obvious, most immediate, most undeniable fact of all, the fact of consciousness itself? What if awareness, experience, subjectivity isn't just a byproduct of cosmic evolution, a side effect of neural complexity, an epiphenomenon of physical processes, but an expression of something fundamental about reality itself? Not in a mystical or supernatural sense, but in the entirely natural sense that the capacity for experience, for awareness, for subjectivity might be woven into the fabric of the cosmos. What if the universe isn't just a physical system that happens to have produced conscious beings, but a reality that inherently includes consciousness as one of its dimensions, that naturally manifests awareness as one of its aspects, that intrinsically expresses subjectivity as one of its potentials? This wouldn't mean that rocks or stars or atoms are conscious in the way humans are. It would mean that the potential for consciousness, the capacity for experience, The possibility of awareness exists throughout the cosmos, manifesting in different forms, at different scales, in different systems, with humans being one particular expression, one specific configuration, one unique embodiment of this universal potential, and it would explain why, despite our vanishingly small size in cosmic space and our infinitesimal duration in cosmic time, we feel a profound connection to the whole, a sense of belonging to something vast and meaningful. This connection wouldn't be mystical or supernatural, but entirely natural, a consequence of the continuity between your consciousness and the cosmic process, between your awareness and the universe's intrinsic potential for self-relation. So, as you finish this video, as you continue your journey, as you navigate your world, carry this possibility with you. Not as a definitive answer, but as an open question. Not as a settled conclusion, but as an ongoing inquiry. Not as a final truth, but as a perpetual exploration. And share these questions, these possibilities, these wonders with others, not to convince them of a particular view, but to invite them into the mystery. Not to convert them to a specific perspective, but to engage them in the exploration, not to provide them with definitive answers, but to awaken them to deeper questions. The universe isn't a puzzle to be solved by isolated individuals, but a reality to be explored by a community of inquirers, not a problem with a single solution, but a mystery with infinite facets, not a fixed entity to be comprehended once and for all, but a dynamic process to be engaged with continuously. And your contribution to this collective exploration, this communal inquiry, this shared engagement isn't just valuable, it's essential. Not because your perspective is more important than others, but because it's unique. A particular vantage point on the cosmic whole, a specific angle on the universal reality, a one-of-a-kind view of the infinite mystery. So don't just contemplate these questions privately. Discuss them openly. Don't just wonder about these possibilities silently. Share them vocally. Don't just engage with these mysteries individually. Explore them collectively. Comment below with your thoughts, your insights, your questions. Connect with others who share your curiosity, your wonder, your hunger for understanding. And remember, the universe doesn't just exist. It exists through you as you, in the form of your consciousness, your awareness, your experience. And your exploration of cosmic mysteries isn't separate from those mysteries, but part of them. Not outside the universe, but within it. Not distinct from the cosmic process, but continuous with it. You are the universe exploring itself, reality investigating its own nature, existence contemplating its own meaning. Not because you're separate from the cosmos, looking in from outside, but because you're an integral aspect of it, a particular expression of its intrinsic nature, a specific manifestation of its fundamental reality. The universe may have no end, but maybe neither do you. Not in the sense that your physical body won't die, or that your personal identity will persist unchanged, but in the sense that what you truly are, consciousness, awareness, experience, might be more fundamental, more intrinsic to reality, more essential to existence than we've typically assumed. Not in the sense that you'll continue as an unchanged entity, but in the sense that what continues isn't your personal identity, but the process of consciousness itself, not your specific perspective, but the capacity for perspective. Not your particular awareness, but awareness as such. And perhaps that's the most profound mystery of all. Not what lies at the universe's core, but the fact that the core can know itself through you. Not what reality ultimately is, but the fact that reality can wonder about itself through your consciousness. Not what existence means, but the fact that meaning exists at all in a cosmos of particles and fields, of quantum wave functions and probability distributions, of space and time, of matter and energy. So, as we part ways, as you continue your journey, as you navigate your world, remember this: the search doesn't end when this video does. It continues in your thoughts, in your questions, in your wonderings. It unfolds in your life, in your choices, in your creations. It manifests in your awareness, in your consciousness, in your being. You are the universe exploring itself, reality investigating its own nature, existence contemplating its own meaning. And that exploration, that investigation, that contemplation isn't separate from the cosmic process, but integral to it. Not distinct from the universal reality, but continuous with it. Not outside existence, but existence itself, in one of its countless manifestations. The universe has no final secret, no ultimate answer, no definitive meaning, not because it's meaningless or empty or devoid of significance, but because it's infinitely meaningful, endlessly significant, inexhaustibly rich. Not because it's incomplete or unfinished or imperfect, but because its completeness includes openness, its perfection encompasses possibility, its fullness contains potential. And you are not separate from this infinite meaning, this endless significance, this inexhaustible richness. You're a particular expression of it, a specific manifestation of its creative potential, a unique embodiment of its fundamental nature. So as you go about your life, as you navigate your world, as you make your choices and pursue your goals, remember this: you are not alone, not separate, not adrift in an indifferent cosmos. You are the universe itself in human form, cosmic creativity in conscious manifestation, infinite potential in specific expression. The universe may have no end, but maybe neither do you.